Hey there, friend. Come on in, get comfortable. Wherever you're sitting tonight, on a couch in bed, maybe with a pillow already tucked under your arm, go ahead and get settled in properly. This is one of those stories that goes down best slow with something warm nearby. A cup of tea, some cocoa, or if you want to be a little poetic about it tonight, maybe a plain glass of milk, since that happens to be exactly where we're headed. Because tonight we're talking about milk. Not the way you're used to thinking about it. Somewhere between 7,000 and 10,000 years ago, drinking milk as a full-grown adult should have made almost every single human being on Earth painfully sick. It was never supposed to happen. Not to you, not to me, not to anyone past the age of a nursing infant. And yet right now, while you're listening to my voice, there's a single letter buried deep inside your own genetic code that quietly decided otherwise. One letter changed everything that came after it. Before we go any further, though, I want to ask you for something small. If stories like this feel like a little escape for you, the kind of thing that makes your evening a bit softer, it would mean more than you know if you tap that subscribe button and maybe left a like on your way there. And I'm curious tonight. Drop a comment and tell me where you're watching from and what time it is where you are right now. I read every one of them, and honestly, it makes this feel a lot less like me talking into an empty room and a lot more like we're sitting somewhere quiet together. Alright, go ahead and dim the lights a little more if you can. Maybe switch on a fan or let the air conditioner hum softly somewhere behind you. Something steady to sit underneath my voice. Get yourself comfortable, because we're about to travel back a lot further than most history classes ever bother to go. In a river valley somewhere in what we would now call Central Europe, morning arrived the way it always did. Slow, grey, patient. Mist sat low over the water, thick enough that the far bank almost disappeared into it. Cattle shifted behind a fence of woven branches, huffing softly in the cold. Somewhere close by, a rooster tried and mostly failed to convince the sun it was time to get up. And from the roof of one small longhouse, smoke rose in a thin, unhurried line, carrying with it the smell of embers and damp earth and something warm cooking slowly over the fire. Somewhere out past the fence, the girl's father was already awake, moving slowly among the animals, checking each one the way he did every single morning, without fail, more out of habit by now than actual worry. The herd was small. It was everything the family owned that truly mattered, and everyone in that house understood it that way, even the smallest ones who couldn't yet put the feeling into words. Inside that longhouse, a young mother knelt beside the hearth. In her hands a shallow clay bowl, and inside the bowl something pale and warm poured fresh that morning from one of the family's goats. Across from her sat her daughter, a small girl, maybe 3 years old, with dirt still tucked under her fingernails from yesterday's play, and an expression far too patient for someone that age. The kind of patience children learn quickly when they're hungry, and when they know food is coming, and all they have to do is wait a few more seconds for it. The mother lifted the bowl toward her daughter's mouth, and paused, just for a moment. Because in this village there was an old rule. Nobody had ever written it down anywhere, since nobody there could write in the way we understand it today, but everyone knew it by heart anyway, the way you know a rule your grandmother taught you, long before you understood why it mattered. Milk was food for the smallest children only, the babies, the ones still nursing, still soft, still brand new to the world. Once a child grew past a certain age, the milk was supposed to stop. Not because anyone was being cruel about it, but because for almost every child who kept drinking it past that age, it made them sick, cramping, bloating. Long, miserable nights that nobody in a small house with thin walls ever slept through quietly. The mother had seen it happen with her own eyes 2 summers back to her sister's boy. Sturdy little thing could carry water better than children twice his age. And then one evening his grandmother, out of pure fondness, let him finish an entire bowl of goat's milk instead of stopping him halfway through the way she was supposed to. By nightfall he was doubled over on the floor mat, sweating, crying, frightened out of his mind and frightening everyone else in the process. So the rule held. It always held. Milk was for the smallest ones, and everyone older drank water or broth or whatever the season happened to provide. More than once the young mother had considered simply stopping, cutting her daughter off from the milk the same way every other family did, just to be safe, just to fit quietly into what everyone else was already doing. It would have been easier that way in a village small enough that everybody noticed everything. But every time she reached for that decision, something held her back. Maybe it was stubbornness. Maybe it was something closer to instinct, some small, quiet voice telling her that whatever was happening with her daughter was not a danger worth fixing. Just beyond the fence line, similar mornings were unfolding in every other house along the valley. Smoke lifting from a dozen rooftops. Children stirring awake, most of them already old enough to know that breakfast today would be barley porridge or a bit of dried meat from last autumn. Anything except milk. That particular pleasure belonged only to the very smallest, the ones still small enough to be carried on a hip, except her daughter was different. This little girl had been drinking milk nearly every single day for close to 2 years past the age when she should have stopped completely, and nothing ever happened to her. No cramping, no long nights. If anything, she was one of the strongest children that year in the whole settlement. Quick on her feet, rarely sick. Always the first one finished with whatever small chore she'd been given, usually complaining loudly about it the entire time, which if you've ever spent an afternoon around a 3-year-old you already know is its own particular kind of good health. At first the mother told herself it was simple luck, nothing more. Then slowly she began to wonder if it might be something else. She never mentioned it outside the walls of her own house. Not because it felt shameful exactly, but because it felt strange in a way she had no real words for. Her own mother had said it once, half joking and half serious, resting a hand on the girl's head, that some children were simply milk-blessed, touched by some small kindness from whatever quiet spirits watched over the herd. The family dog, for what it's worth, seemed to share that theory completely, and made his personal opinion known every single morning by parking himself directly beside the girl's bowl, watching her finish every last drop with an expression of deep wounded betrayal, as though she had personally promised him half and then changed her mind. Later that same day, while the sun finally burned the mist off the river, the girl was outside chasing one of the older boys across a muddy patch of ground, shrieking with the kind of laughter only small children seem able to produce before lunchtime. She fell twice, got back up twice, and kept running both times like it hadn't happened at all. One of the other mothers, watching from her doorway with a baby on her hip, called out something about how tired that child must make her poor mother, and the young mother could only laugh and agree because there was no gentle way yet to explain what she was only beginning to suspect. But there was no spirit involved here. No blessing whispered over the milk at sunrise, no small kindness handed down from anywhere above the clouds. What was actually happening inside that little girl's body on that very ordinary morning was something so small that it would take human beings thousands of years to even notice it was there at all. A change tucked deep inside a single thread of hereditary material passed down to her from generations before. One letter, somewhere among billions, quietly rewritten. She had no idea, of course. Her mother had no idea either. Nobody standing in that valley that morning, and nobody standing in any valley anywhere else on Earth, at that particular point in history, had the slightest idea that this one small girl's body was doing something that by every rule nature had followed up until then it simply was not supposed to be able to do. Every other mammal on this planet follows the exact same pattern and always has. You drink your mother's milk as an infant, and then once you're grown, your body quietly closes that door behind you and never opens it again. It happens to kittens. It happens to calves, to lambs, to every creature you've ever watched grow up on a farm or in a nature documentary. And it happened without exception to every human being who'd ever lived before this particular chapter of our story tonight. By every rule that had ever applied to any mammal, it should have happened to her too. And yet here she was. One small girl in one small valley still drinking milk long after her body was supposed to have quietly said no. If you happen to be watching this tonight with a glass of milk sitting somewhere near you, or cheese on a plate in the kitchen, or coffee with a little cream stirred into it, you might want to hold on to that thought for just a second. Because that small, easy ability, the one you probably never think twice about, was not something every human being on this planet was simply handed from the very beginning of our story as a species. It had to start somewhere. It had to start with someone in some ordinary place on some ordinary morning very much like this one. It's such a small ordinary thing, pouring milk into a cup without a second thought. And yet that small ordinary habit is younger than almost anything else about being human. Younger than language, most likely. Younger than the wheel. It is one of the newest tricks our species has ever learned to perform, and most of us walk around never once realizing we're performing it at all. We tend to think of evolution as something that happened a very long time ago, safely finished, tucked away in museum displays and old textbooks. But this particular change was still being written, one quiet birth at a time, in valleys like this one long after humans were already building homes, raising animals, and telling their own children old rules about milk that would eventually turn out to be wrong. Maybe it even started with her. We can't know her name. We'll never know her face or what her laugh sounded like or whether she grew up stubborn or gentle or somewhere in between. What we do know is that she was ordinary in every other way that mattered. She probably argued with her mother about eating vegetables. She probably had a favourite spot by the fire, and a least favourite chore, and a laugh that annoyed somebody in that house at least once a day. History did not save her name, because history at that point was not yet in the business of saving anyone's name. It only kept the changes people carried inside them quietly, and passed on without ever meaning to. But we do know this much for certain. Somewhere in a valley like this one, a child like her was born carrying one small invisible difference. And that difference did not stay quietly tucked away inside one family, in one house, in one river valley forever. It spread, slowly at first, almost as if it were waiting for the right moment. And to understand how one small, completely unnoticed change in one small girl could eventually travel thousands of years and thousands of miles and land somewhere as ordinary as your own kitchen tonight, we have to step back even further than this valley. Back to a rule that every mammal on this earth has followed since the very beginning of life itself, and the reason that rule exists in the first place. That's exactly where we're headed next. To understand why a little girl in that valley stood out at all, we need to step away from goats and clay bowls and quiet river mist for a moment. We need to talk about something that has nothing to do with any particular place or any particular century. We need to talk about a rule so old, so deeply stitched into the story of life on this planet, that it applies to you right now tonight, whether you've ever thought about it or not. Here is the honest, slightly uncomfortable truth of it. If you are an adult and you can drink a glass of milk without your stomach staging some kind of small rebellion afterward, you are in a very real biological sense breaking a rule that almost every mammal before you was born to obey. Every one of them. No real exceptions for most of the history of life on Earth. So let's talk about that rule for a while, where it came from, why it exists at all, and just how strange it actually is that so many of us walk around today getting to ignore it completely most of the time without ever once realizing we're doing it. Quick question for you before we go any further. Do you remember the last time you drank your mother's milk? Of course you don't. Nobody does that. Memory sits somewhere below where any of us can reach it. But your body remembers in its own way, written into the same biological instructions every mammal on Earth carries. And what it remembers is a rule most of us have never once thought to question. Every mammal on this planet begins life more or less the same way. A newborn arrives into the world completely unable to feed itself, unable to chew, unable to hunt or forage, unable to do much of anything at first except cry and demand attention, which if you've ever spent an evening around a newborn of any species, you already know they are remarkably talented at. And so, somewhere far back in the deep evolutionary past, nature landed on one elegant solution still used today by roughly 6,000 different mammal species, humans very much included. Milk. Milk is not simply food if you stop and actually look closely at what's inside it. It behaves more like a complete life support system delivered in liquid form. Fat for energy. Protein for building muscle and bone at a pace that would exhaust an adult body. And a particular sugar called lactase found almost nowhere else in nature except inside a nursing mother's own body. That sugar happens to be the entire reason we're sitting here with this story tonight. Lactose on its own is a little too large and too awkward a molecule for your small intestine to absorb directly. Your body has to break it apart first into two simpler sugars it can actually put to use. And the tool responsible for that breaking apart is an enzyme called lactase produced by cells lining the wall of your small intestine, working quietly, almost invisibly, every single time milk makes its way through your system. Picture lactose as a locked door for a moment and lactase as the only key shaped correctly enough to open it. No key, no way through. The sugar simply sits there instead, undigested, drifting further down into your gut, where it begins to ferment, pulling in extra water along the way and feeding a small army of bacteria who are frankly having the best day of their entire short bacterial lives, which is really just a gentler way of saying that is precisely where cramping, bloating, and those long uncomfortable nights we talked about earlier actually come from. Every baby, human or otherwise, is born with that key turned fully on. Lactase production runs high right from the very first feeding, because for a while milk is quite literally the only thing standing between that baby and starvation. And then at some point quietly, without asking permission, nature takes the key back. This isn't an accident. It isn't some flaw the body develops by mistake. It happens exactly according to plan, and has for longer than most of us can comfortably picture. Producing milk costs a mother an enormous amount in energy and nutrients pulled straight out of her own body night after night for months on end. From nature's cold, practical point of view, once a young animal grows old enough to chew, to hunt, to forage, to eat whatever everyone else around it is already eating, there stops being much reason to keep manufacturing an enzyme built for a food source it no longer strictly needs. So gradually, without any drama at all, the body quietly turns that gene down. Not fully off in most mammals, but low enough that milk in any real quantity simply stops agreeing with you. And this particular shutdown is old. Older than most of what we would call human history combined, reaching all the way back to the earliest mammals that ever walked, swam or scurried across this planet tens of millions of years before anything resembling a human being had even shown up to the party. If you want proof of exactly how strict this rule usually is, you don't have to look any further than the rest of the animal kingdom, and honestly, some of the examples are almost funny once you hear them. Take the hooded seal, a fairly large, dramatic-looking creature living in the freezing waters of the North Atlantic. A hooded seal pup nurses for roughly 4 days total. 4 days and then it's done, fully weaned, expected to survive completely on its own out in the open ocean. 4 days. Meanwhile, some of us still need a full 2 weeks just to properly get over a head cold. While we're on the subject of surprising exceptions to expect, here's one that might ruin a childhood cartoon memory for you. every full-grown cat that has ever happily lapped up a saucer of milk in an old film or storybook was biologically making a fairly poor decision. Adult cats lose most of their ability to digest lactose too, exactly like the vast majority of mammals we've been discussing tonight, which means that sweet little bowl of milk left out on a porch somewhere is far more likely to upset a grown cat's stomach than to make it happy. Nature, it turns out, does not make exceptions just because something looks charming in a painting. Or think about the blue whale, the largest animal to have ever lived on this earth, bigger than anything the dinosaurs ever managed to grow into. A blue whale calf can gain close to 90 kilograms of body weight in a single day, almost entirely from its mother's milk. And yet within roughly 6 to 7 months that calf is completely weaned, shifted permanently onto a diet of tiny shrimp-like creatures, and it never touches milk again for the rest of its enormous life. Elephants sit at the far opposite end of that spectrum, nursing their calves for 4 to 6 years, in some recorded cases among the longest nursing periods of any land mammal alive today. But even elephants eventually stop. The rule always closes the door in the end. It simply decides species by species exactly how long that particular door's allowed to stay open. And if elephants feel a little too far removed from us to make the comparison land, consider our closest living relatives instead. Chimpanzees, the animal whose genetic makeup overlaps with ours more than almost any other creature alive, wean their young somewhere around 4 to 5 years of age. A timeline that, as it turns out, sits remarkably close to what researchers believe was typical for early humans as well. It's a small, humbling reminder that for most of our story as a species we weren't nearly as different from the rest of the animal kingdom as we might like to imagine tonight. So where does our own species fit into that picture? For almost the entire length of human history, long before anyone had invented baby formula or wandered down a grocery store dairy aisle, human children were weaned somewhere between 2 and 4 years of age on average, though that number shifted quite a bit depending on culture climate and the particular century in question. Some societies weaned earlier out of necessity. Others, particularly certain hunter-gatherer communities studied by anthropologists in more recent times, nursed children for 3 years or longer as an ordinary, completely unremarkable part of daily life, nothing anyone thought twice about. Here's something that still catches people off guard when I bring it up. Scientists today can actually look inside a single human tooth thousands of years old and figure out almost exactly when that particular child stopped nursing. Teeth grow in layers a little like rings inside a tree trunk, and each layer quietly locks in a tiny chemical trace of whatever that child happened to be eating and drinking while it formed. A shift in certain chemical markers detectable under the right kind of laboratory analysis shows researchers the precise moment breast milk stopped and solid food took over. Doesn't that feel like a strange thing to sit with for a second? Somewhere in a laboratory right now, a researcher is quietly piecing together the earliest years of a child's life off a single tooth from a person who lived and died long before anyone thought to write anything down. There's actually a whole quiet corner of evolutionary biology dedicated to studying exactly why weaning happens when it does, and it turns out the timing was rarely as peaceful as we might imagine. Researchers who study this call it weaning conflict, and the idea behind it is fairly simple once you hear it laid out. A mother's body has limited resources, and at some point it becomes more useful, evolutionarily speaking, for her to save that energy for a future child, rather than keep pouring it into one who can already chew solid food. The child, on the other hand, has no such incentive to share. From where that child stands, milk is warm, familiar, and free, and there is no particular reason to give it up simply because a parent has decided it's time, which is really just a scientific way of explaining something every single parent throughout history has already discovered on their own, usually around the same difficult week. Weaning was rarely as simple or as calm as anyone hoped it would be. And here's the part of all this that matters most for where our story is going tonight. Once those children grew into adults in every single human population, on every single continent, for the overwhelming majority of our species' entire existence, that same ancient rule applied without exception. Milk was for children. Full stop, no debate, no local variation worth mentioning. It didn't matter whether you were standing on the open plains of Africa, deep in the forests of what we'd now call Europe, or anywhere else our species had managed to spread and settle. Adults everywhere lost the ability to properly digest milk exactly the same way every other mammal on this planet does to this very day. It wasn't a local custom passed down by one particular village. It wasn't a superstition somebody happened to invent out of caution. It was plain biology doing precisely what it had already been doing for tens of millions of years before a single human being ever walked upright. Think about that mother from earlier for a moment, kneeling by her own fire, watching her daughter finish another bowl of milk without the slightest complaint from her small body. She had no way of knowing any of what we've just talked about. No knowledge of enzymes or genetic instructions or ancient rules stretching back tens of millions of years. All she had was what every mother before her had ever had, watching, worrying and quietly noticing when something about her own child refused to follow the pattern everyone else seemed to follow without question, which, if you sit with it for a moment, raises a fair question worth asking yourself honestly. How many other things in your own life do you quietly assume are simply natural, or the way things have always been, without ever once stopping to actually check? Because if you're watching this tonight and you can pour milk over a bowl of cereal or stir a little cream into your coffee without giving it a second thought, you're living proof that rules like this one, no matter how ancient, no matter how deeply built into the biology of nearly every mammal alive, are not actually permanent after all. They can bend. Every so often, quietly, almost without anyone noticing at the time, they can even break completely. Somewhere a very long time after this particular story could have simply stayed exactly the same forever, something did break. Not everywhere at once, not for every person, and certainly not on purpose. But somewhere inside one small, unremarkable population among people who almost certainly had no idea what was quietly shifting beneath the surface of their own bodies, that ancient rule finally met its first real exception. And that exception didn't happen by magic or by luck or by any blessing whispered over a bowl of warm milk at sunrise, no matter what one worried grandmother in one small longhouse might have chosen to believe. It happened because of something almost impossibly small. A change so tiny it exists at a single point along a genetic sequence. Billions of characters long sitting there quietly for generations, hiding in plain sight, long before anyone alive had the tools or even the imagination to go looking for it. It's worth pausing on just how easily this could have never happened at all. Rules. This deeply built into every branch of the mammal family tree, do not bend for no reason. Something had to be different at the smallest possible scale, imaginable, smaller than anything the eye could ever see, smaller even than most of what we tend to think of when we picture the word change. To understand what that change actually was and how something so unbelievably small could override a rule this deeply written into every mammal on the planet, we need to go looking for it directly, down into the actual instructions written inside every one of your cells to the exact spot where one species' entire relationship with milk quietly and permanently changed forever. Every single cell in your body, and there are trillions of them, is quietly carrying around something almost impossible to picture properly. A library. Not shelves and reading rooms, obviously, but built on the same basic idea. Instructions stored letter by letter, page after page, describing in exhaustive detail exactly how to build you from the inside out down to the smallest working part. Try holding that image for just a second. Trillions of tiny copies of the exact same library tucked inside nearly every cell you own, from the ones lining your stomach right now to the ones sitting behind your own eyes as you watch this. Every copy identical. Every copy silently doing its job without asking for any credit. And somewhere buried deep inside that library on one particular page inside one particular book sits the single sentence responsible for everything we talked about a few minutes ago. One tiny edit made to one single word inside a text so long that if you actually tried to print the whole thing out using an ordinary size font, you would need something in the neighborhood of 1,000 thick books just to hold it all. Your entire genetic code is written using only 4 different chemical letters repeated over and over in endless combinations roughly 3 billion times over. Scientists gave those 4 letters proper names a long time ago. Adenine, thymine, cytosine, guanine. 4 letters rearranged in every conceivable order, spelling out everything from the color of your eyes to the shape of your hands to whether or not you happen to be sitting here tonight fully capable of finishing a glass of milk without a single word of complaint from your stomach. Here's a fact worth sitting with for a moment because it tends to surprise people. That entire enormous library is not actually finished being written. It never has been. Every single time one of your cells divides an internal scribe of sorts has to copy the whole thing out, again, letter for letter, an almost unbelievable act of precision, repeated inside your body millions of times a day without you ever noticing a bit of it. And like any scribe, copying an impossibly long manuscript by hand over and over for generation after generation, mistakes occasionally slip through. A letter gets copied wrong. A tiny typo buried somewhere inside 3 billion characters. That in the simplest possible terms is what a mutation actually is. Not the dramatic, glowing, superhero origin kind of event most of us picture from films and comic books, but something closer to an ordinary copying error, the genetic equivalent of a tired monk, accidentally writing the wrong letter somewhere around page 400,000 of a book. He has already copied out 1,000 times before. Most of these small errors do absolutely nothing at all. They land somewhere harmless in a stretch of the library that isn't being actively used at that particular moment, and life carries on completely unaffected. A smaller number of them cause real damage, sometimes devastating damage, which is exactly why the word mutation earned such a frightening reputation in the first place. But every so often, exceedingly rarely, one of these small accidental errors lands in exactly the right place, at exactly the right moment in a person's life, and instead of breaking something, it quietly improves it. Picture a printing error inside an old family recipe book. Most typos in a recipe don't matter much at all. A few completely ruin the dish. And once in a great while, by pure accident, a misprinted line accidentally makes the recipe better than the original ever was. Somewhere in your own body right now, this same quiet process is still happening page after page, completely unnoticed. Most of what gets copied slightly wrong today will mean nothing to anyone ever. A rare few of tonight's tiny errors, statistically speaking, might mean everything to somebody several thousand years from now, in a story nobody alive today will ever get to hear told. This part of our story tonight belongs firmly in that last rarest category. Most of us grow up assuming a gene works something like a light switch sitting right next to the lamp it controls. Flip it, the light comes on, simple as that done. But biology, as it usually turns out, is rarely that tidy. Many of the most important switches inside your genetic material do not sit anywhere near the thing they actually control. They sit somewhere else entirely, sometimes thousands of letters away, tucked inside a completely different gene altogether, one that on the surface appears to have nothing whatsoever to do with the trait it happens to be quietly running from a distance. You already know from a few minutes ago about the enzyme called lactase, and about the gene responsible for building it. What almost nobody guesses correctly on their first attempt, including plenty of people who consider themselves fairly well informed on the subject, is exactly where the actual switch controlling that gene turned out to be hiding. For years, researchers reasonably assumed that if lactase production somehow stayed switched on into adulthood, the explanation would be sitting somewhere inside the lactase gene itself. That seemed like the only logical place to look, except it wasn't there. Scientists went searching gene by gene, letter by letter, and came back completely empty-handed from inside the lactase gene itself. Whatever they were looking for was hiding somewhere else entirely. It eventually turned up inside neighbouring gene 1 that, as far as anyone has ever been able to tell, has nothing whatsoever to do with milk or digestion or lactose of any kind. That neighbouring gene spends its ordinary working life helping cells copy their genetic material correctly whenever they divide a job with no obvious connection to breakfast at all. But buried deep inside one small quiet stretch of that gene, a stretch that doesn't even build anything of its own, sits a single switch. And that switch, for reasons that still feel slightly poetic even now, reaches across the distance and controls the lactase gene sitting nearby, the way a spare set of keys left inside a completely different house down the street can still somehow unlock the door of the house right next to it. That switch sits precisely 13,910 genetic letters upstream from where the lactase gene itself actually begins, and at that exact address, in some people, one single chemical letter, cytosine, has been quietly swapped out for a different one, thymine. That's the whole mutation in its entirety. One letter traded for another at one single spot out of roughly 3 billion possible addresses across your entire genetic code. If your full genetic code really were printed out across 1,000 books, the way we imagined a moment ago, this particular change would be one single character on one single page inside one single book, sitting there completely unnoticed by any human being on Earth for tens of thousands of years. Here's what that one swapped letter actually does in practice. Ordinarily, in every mammal, without this particular change, a small crew of specialized proteins arrives at that switch sometime in early childhood and gently begins dimming it the way a shopkeeper quietly starts lowering the lights and locking up as closing time approaches for the evening. Lactase production slows. Eventually it drops close to nothing. But in a person carrying that one swapped letter, those same proteins arrive at the switch, and for reasons researchers are still working out in fine detail, even now seem to lose their grip on it completely. The lights stay on. The shop, against every expectation nature had ever set up, simply never closes for the night. And here's a detail worth clearing up properly, because it trips up almost everyone who hears this story second-hand for the first time. This mutation did not hand anyone some brand new ability that never existed before. Every human being alive today, whether they can comfortably finish a full glass of milk or not, is born carrying a perfectly functional lactase gene, every single one of us without exception. The ability to digest milk was never invented by this particular change. It was already sitting there quietly inside every one of us from the very beginning, the exact same way it sits inside every newborn baby ever born on this planet. All this mutation actually does, this one swapped letter, is prevent that ability from being switched off on its usual schedule. It builds nothing new whatsoever. It simply leaves a door standing open that in almost every other human being throughout almost all of history was always supposed to close. Isn't that a strange way for evolution to work if you sit with it for a second? Not by inventing something new from scratch the way we tend to imagine evolution operating, but by quietly failing to shut something old down properly, and that particular failure turning out against every reasonable expectation to be an enormous advantage. Here's another question worth asking yourself while we're on the subject. Out of the countless tiny copying errors scattered across your own genetic library right now, most of them completely invisible, completely harmless, doing absolutely nothing at all, how many of them might be sitting there quietly waiting for the right set of circumstances to matter the way this one eventually did? Scientists did not stumble onto any of this by pure accident either, and the story of how they actually tracked it down is worth knowing properly. In the early 2000s, a team of researchers working in Finland began studying families where some members could drink milk comfortably well into adulthood, while their own siblings raised in that very same household eating dinner at that very same table, their entire childhood absolutely could not. That kind of split showing up cleanly inside a single family is exactly the sort of clue geneticists spend entire careers hoping to find, because it strongly suggests something specific, something traceable, passed down unevenly from parent to child, the way a family heirloom might go to one sibling and not another. By comparing genetic material across dozens of these families piece by piece, letter by letter, researchers slowly narrowed an entire search down from 3 billion possibilities to a single precise spot. 13,910 letters upstream, and there it was sitting quietly waiting to be noticed after tens of thousands of years of going about its work in complete silence. It's worth pointing out that this kind of finding is not something that happens quickly or easily, or on the first attempt. The researchers involved were not simply guessing and getting lucky. They were sifting through enormous amounts of genetic material family by family, comparing sibling to sibling, checking their own results against each other again and again before anyone was willing to say, with any real confidence, that they had actually found the answer. Science at its best moves at exactly that pace. Slow, careful, occasionally frustrating, and every so often quietly thrilling in a way that rarely makes headlines outside of a small circle of people who have spent their whole careers waiting for a moment exactly like that one. This particular discovery would go on to become one of the most well-documented examples scientists have ever found of something researchers call gene culture coevolution, a fairly academic-sounding term for a fairly beautiful idea. The notion that a change in human behavior, in this case the decision to start keeping animals for milk, and a change in human biology, this one swapped genetic letter, can end up shaping each other back and forth across thousands of years, neither one able to fully explain our story without the other standing right alongside it. What makes this particular discovery unusually satisfying, at least to my mind, is just how rare a story like this actually is in modern genetics. Most human traits worth talking about, height, general health, the way a person's mind works, are influenced by hundreds, sometimes thousands of different genetic factors, all working together in combinations too complicated for anyone to fully untangle. This one, by comparison, came down to one single letter at one single address doing one single job. Clean, precise, almost stubbornly simple in a field of science that is very rarely either of those things. There's something almost moving about that if you let yourself sit with it for a moment longer. An enormous team of trained researchers working with genetic sequencing tools, it took our entire species roughly 4 billion years of evolution to eventually stumble into building spent years of careful, patient, occasionally frustrating work, all in pursuit of understanding one small, oddly specific thing. Why some people and not others can finish a glass of milk without quietly regretting it a few hours later. But here's the piece of this puzzle that a single genetic switch still couldn't explain on its own, and it's worth sitting with before we move any further tonight. A switch like this one is completely useless without something real for it to actually control. There is no advantage whatsoever to keeping your ability to digest milk switched on for your entire life if there happens to be no milk anywhere nearby for you to actually drink in the first place. Which means this particular mutation, remarkable as it is, could never have spread anywhere on its own merit, no matter how clever it happened to be. Think about it this way if it helps. Owning the world's most reliable, always open front door is not particularly useful advice for someone living nowhere near a road. The switch existed. The opportunity to actually use it did not for a very long time after this particular mutation first appeared somewhere in someone's genetic material, quietly doing absolutely nothing at all. It needed something else to happen first. It needed animals capable of producing milk in any real dependable quantity, kept close enough and trusted enough to be milked by human hands in the first place, something no human being anywhere on Earth had ever managed to arrange before a particular moment in our shared history. And for that piece of the story, we have to leave this single genetic switch behind for a while. Step outside the library entirely and travel somewhere else. To the exact stretch of land on this planet, where a group of humans first looked at a wild, wary animal and decided against every instinct that had kept their ancestors alive for tens of thousands of years, that keeping it close rather than simply hunting it down might actually be worth trying. Picture for a moment a stretch of land curling gently across an old map shaped so distinctly that geographers eventually gave up trying to find a more official-sounding name for it, and just started calling it exactly what it looked like: a crescent. Fertile ground curving from the eastern edge of the Mediterranean up through what is now the country of Turkey, and back down along two great rivers toward the Persian Gulf. History books like to hand this particular stretch of land a rather grand title: the cradle of civilization, which sounds like a phrase invented by someone who never actually tried surviving there through a single harsh winter without modern conveniences, but the title, dramatic as it sounds, turns out to be fairly well earned, because it was here roughly 10,500 years ago, give or take a few centuries depending on which archaeological site you happen to ask, that a small number of human communities did something no group of people anywhere on Earth had managed to pull off before. They looked at wild, easily startled, occasionally quite dangerous animals, and instead of simply hunting them down whenever hunger arrived, the way their own ancestors had for longer than anyone could remember, they decided to try something considerably riskier. Keep a few of them close, generation after generation, and see what happened. It helps to understand why this particular corner of the world and not somewhere else ended up being the stage for that experiment. The last great ice age was finally loosening its grip on the planet around that same period, and as the climate warmed and settled into something closer to what we'd recognize today, wild wheat, wild barley, and herds of wild sheep and goats all happened to concentrate naturally across this one curved stretch of land, practically arranged by pure geological accident into everything a hungry, curious species might need to start experimenting with an entirely new way of living. The earliest solid evidence for this particular gamble comes from the Zagros Mountains in what is now western Iran, at a site archaeologists call Ganj Dara. Long before anyone in that region thought to write anything down, herders there were managing wild goats in a way that left behind a very particular, very telling clue, buried quietly for thousands of years inside the bones themselves. Here's how researchers actually pieced this together, and it's a cleverer bit of detective work than most people give it credit for. When humans hunt wild animals purely for food, they tend to kill whatever happens to cross their path, a fairly even mix of males, females, young and old, with no particular pattern to speak of. But when humans start managing a herd on purpose, deciding which animals live and which get eaten, that pattern shifts dramatically. Young males contributing nothing toward future breeding get slaughtered early. Female goats, valuable for producing the next generation, get allowed to live on for years longer than any hunted animal ever would. At Ganj Dareh, when researchers carefully examined the ages and sexes recorded in thousands of ancient goat bones, that exact lopsided pattern showed up clearly dating back roughly 10,000 years. Nobody needed a single written record to prove humans were managing herds deliberately by that point. The bones themselves told the whole story once someone finally thought to ask them the right question. It's worth noting too that not every animal arrived at domestication the same way, and the differences say something interesting about the animals themselves. Goats and sheep were, relatively speaking, the easier partners in this whole arrangement. Herd animals, by nature already inclined to follow a leader and stay close to a group, qualities that made the transition to human management smoother than you might expect. Dogs, for what it's worth, seem to have taken an entirely different route into our lives a few thousand years earlier, still drifting toward human campfires on their own. Initiative scavenging scraps, gradually growing tamer over generations, without anyone deliberately planning it that way at all. Cattle offered neither shortcut. Wild, powerful, and instinctively distrustful of anything walking on two legs, they had to be won over the hard way through nothing but patience, careful selection, and no small amount of risk to whoever was standing closest at the time. Cattle took a fair bit longer to join the picture, and honestly, once you know the details, it's easy to understand exactly why. The wild ancestor of every dairy cow, beef animal, and rodeo bull alive today was a creature called the aurochs. And if you're currently picturing something similar to a modern cow standing patiently behind a fence, you should probably picture something considerably less polite instead. Aurochs stood well over 6 feet tall at the shoulder, in some recorded cases built like an animal that had never once lost a fight. It didn't personally choose to walk away from carrying horns fully capable of goring a careless hunter straight through if an encounter went badly. Cave paintings scattered across parts of Europe, tens of thousands of years old in places, depict these creatures with an almost reverent sense of danger, the particular respect ancient artists tended to reserve for things that could actually kill them without much effort. Domesticating an animal built like that was never going to be a short project. It took generations of remarkably patient, remarkably brave people, deliberately selecting the calmest individuals out of each new generation, slowly breeding a wild, thoroughly formidable animal down into something closer to what eventually became the familiar, fairly good-natured cow most of us picture today. And here's a detail that still catches me off guard every single time I sit with it properly. Genetic studies of cattle alive right now, every dairy cow and every beef animal scattered across the entire planet, trace their ancestry back to a surprisingly small founding population. Somewhere in the neighborhood of 80 individual aurochs, domesticated at roughly the same time in roughly the same corner of the world. 80 animals. Every glass of milk, every wedge of cheese, every burger anywhere on Earth tonight exists because of a genetic bottleneck that narrow that fragile sitting right at the base of the whole family tree. The aurochs itself as a wild species didn't survive our story much longer after that. Hunting pressure, shrinking habitat, and centuries of competition from the very species that had also managed to tame some of its relatives slowly wore the wild population down to almost nothing. The very last known aurochs on the planet, a lone female, died of natural causes in a forest in Poland in the year 1627, which means the wild ancestor of the modern dairy cow was still alive and wandering the earth at roughly the same period certain far better remembered figures in European history were walking around themselves. A strange thought, honestly, that something feeling this ancient to us tonight actually overlapped with what most of us would casually call fairly modern history. Now here's where this story takes a turn that tends to surprise almost everyone who hears it laid out properly for the first time, myself included the first time I looked into it carefully. You might reasonably assume that once humans had these animals safely under their control, milking would have started almost immediately afterward. It didn't, not even close. The archaeological evidence actually tells a very different story, one that unfolds across a gap of roughly 2,000 years between one milestone and the next. Early farmers domesticated goats, sheep, and eventually cattle, primarily for meat for hides, for the simple practical comfort of having food nearby that couldn't run quite as fast as it used to. Milk, strange as this sounds to modern ears, appears to have arrived almost as an afterthought. The earliest solid evidence we actually have of humans processing milk in any real quantity comes from pottery fragments unearthed in the northwestern regions of what is now Turkey, dated to roughly 8,000 years ago. Fatty residues chemically trapped inside the clay itself for thousands of years, preserved well enough for modern laboratory equipment to identify exactly what those ancient vessels once held long after everyone who ever used them had turned to dust. Which means there's a real measurable gap roughly 2,000 years wide sitting quietly between the moment humans first started keeping these animals close and the moment they actually began drinking what those animals had to offer in any serious organized way. And milk wasn't the only benefit hiding behind that delay either. Wool useful for weaving warm clothing and the practice of harnessing cattle to pull plows and carts both arrived on a similarly delayed timeline well after the animals themselves had already been living alongside humans for many centuries. Researchers studying this pattern across the whole region eventually gave it a name, calling it something like a second wave of innovation layered on top of the first. Domestication itself was only step one. Figuring out everything an animal could actually offer beyond meat and hide took a great deal longer and unfolded far more unevenly than most of us tend to assume when we picture how farming simply appeared fully formed one convenient morning. Why the delay specifically around milk? It's worth pausing on that question for a moment because the answer says something rather interesting about how new ideas actually spread through a society, both then and if we're being honest with ourselves now as well. Milking an animal, especially in those earliest days, was not a simple or obvious thing to figure out from scratch. It required trust built patiently across generations, animals calm enough to tolerate human hands, in a way their wild ancestors never remotely would have allowed. It required watching a young animal nursing from its own mother, and somehow arriving at the idea that a human being might be able to take a share of that same resource for themselves, a leap of imagination that, viewed honestly from the outside, is a fairly odd thing to attempt the very first time. And beyond the simple practical difficulty of it, there was the small matter we already spent quite a while discussing earlier tonight. Nearly every single adult human being alive at that point in history still lost most of their ability to properly digest milk sometime in early childhood, exactly the way nature intended for every mammal on this planet, no exceptions worth mentioning yet. Which means that for a very long stretch of this story, humans were producing something their own bodies, almost without exception, were not yet properly built to use. There's a reasonably compelling idea favoured by quite a few researchers who study this period closely about how the whole practice might have gotten started in the first place, almost by accident. Young animals die. It happened then just as it happens now, sometimes from illness, sometimes from simple bad luck, leaving a mother goat or a mother sheep with milk still coming in, and no offspring left to drink it. A farmer standing nearby watching that surplus quite literally go to waste would hardly need much imagination to wonder whether some of it might be put to better use elsewhere. It's a small, almost mundane origin story for something that would eventually reshape diets, economies, and even human genetic material itself across an entire continent. But history, in my experience anyway, tends to start in far smaller, far less dramatic places than we like to imagine looking back on it. There's something almost poetic buried in that fact if you allow yourself to sit with it for a second. An entire agricultural revolution, one of the most consequential turning points in the whole story of our species, built partly around a resource that for most of the people directly involved came attached to a fairly rough physical price tag. And yet they kept at it anyway. Kept experimenting, kept quietly passing the practice down to their own children generation after generation, long before a single one of them understood why some households seemed to handle it noticeably better than their neighbours did. Have you ever wondered how many truly world-changing ideas started out as nothing more than somebody's slightly odd experiment, the kind of thing their own neighbours quietly raised an eyebrow? At first I find that thought oddly comforting, if I'm honest with you. Somewhere in one of these early farming communities tucked into a valley whose name got lost long before history started keeping proper track of such things, somebody must have been the very first to notice a pattern most of the people around them hadn't spotted yet. That milk prepared a certain way, handled a certain way, or perhaps only given to certain members of the household, seemed to cause noticeably less trouble than everyone had simply come to expect. We'll never know that person's name the same way we could never quite put a name to that little girl from earlier in tonight's story either. History at that stage still wasn't in the habit of keeping anybody's name for very long. If you'd been standing in one of these early settlements yourself watching a neighbour attempt something as unusual as milking a wild-tempered goat for the very first time, be honest with yourself for a second. Would you have tried it too right alongside them, or would you have quietly waited a season or two just to see how it actually worked out for somebody else first? So here's where all of this leaves us tonight. Animals finally properly domesticated, milk finally flowing at least in small, hard-won quantities after generations of patient, occasionally dangerous work. And sitting right alongside that same story, human bodies still mostly unequipped to make full use of any of it. That same ancient rule we spent so much time on earlier, still firmly stubbornly in place for almost everyone involved. Which leaves an obvious question hanging in the air tonight, one worth carrying with you into what comes next. If nature hadn't yet handed most of these people the biological tool to properly digest milk, and wouldn't, for many thousands of years still to come, how did an entire way of life built around dairy manage to survive at all? Never mind thrive, simply survive long before that genetic switch we spent so much time on earlier ever became common enough to matter. The answer has almost nothing to do with quietly waiting around for evolution to eventually catch up. It has everything to do with what these early farmers figured out how to do cleverly, patiently, with nothing more than their own two hands and a willingness to keep experimenting until something finally worked. If biology wasn't going to solve this particular problem anytime soon, and by every measure we've already talked about tonight it clearly wasn't, then somebody somewhere was eventually going to have to solve it a different way. Here's a question worth sitting with for a moment before we go any further. When you picture a major turning point in human history, what usually comes to mind? A battle, maybe? A discovery made in a laboratory? Some dramatic, deliberate act of genius? Rarely, if ever, do we picture a leaking bag left out in the sun a little too long, and yet that unglamorous, faintly embarrassing scenario may be exactly how one of the most important food inventions in human history actually came about. Think for a second about how many things sitting in your own kitchen right now started out as somebody's mistake. Bread rising because forgotten dough was left out too long, wine happening because grape juice sat around longer than intended. History has a strange habit of rewarding the people willing to taste the thing that went wrong, instead of throwing it out immediately. And tonight's story is about to give you one of the oldest examples of exactly that habit. For thousands of years, long before anyone had access to glass jars or clay pots sealed properly enough to hold liquid without seeping, herders needed some practical way to carry milk from one place to another. And one of the most convenient containers available to them, oddly enough, came from the animals themselves. The stomach of a freshly slaughtered goat, sheep, or young calf, cleaned out and dried, made a surprisingly sturdy, lightweight pouch, the kind of thing a herder could sling over one shoulder without a second thought. Here's the detail that changes everything about that seemingly ordinary choice. The inner lining of a young ruminant's stomach naturally contains an enzyme that helps that animal digest its own mother's milk. When fresh milk was poured into one of these stomach pouches and left to sit for a while, jostled along on a hot afternoon walk, that same enzyme would quietly get to work on the milk itself, curdling it, separating it into a soft solid mass and a thin watery liquid. A herder opening that pouch later expecting plain milk would have found something else entirely waiting inside. Something with a completely different texture, a completely different smell, and as it eventually turned out, a completely different relationship with the human digestive system than the milk that had gone in. Picture the moment itself for a second. A tired herder somewhere on a dusty path untying a stomach pouch, expecting the same thin, familiar liquid it always held, only to find something thick, pale and faintly sour sitting inside instead. There would have been an obvious sensible reaction available in that moment. Toss it out. Blame the heat tie a fresh pouch next time. History could very easily have gone that way, and cheese might have taken thousands of extra years to arrive at all. Instead, somewhere more than once somebody made a different, slightly braver choice. Nobody planned that discovery. Nobody woke up one morning with a grand vision for a brand new food category. It almost certainly happened by accident more than once in more than one valley, long before anybody understood the slightest thing about enzymes or bacteria or why the result tasted the way it did. Somebody at some point worked up the nerve to actually try the strange curdled substance sitting inside that pouch instead of throwing it out. And whoever that person was, they stumbled onto something that would eventually outlast empires. Let's talk for a moment about what was actually happening inside that pouch, because the science behind it matters quite a bit to where our story is headed tonight. When milk curdles, whether through that natural stomach enzyme, or through something as simple as a splash of something acidic, it separates into two distinct parts. The solid portion, made mostly of proteins and fat clumped together, is what eventually becomes cheese. The thin, watery liquid left behind is called whey. And here's the detail that matters most for us tonight. Lactose, that troublesome milk sugar we've spent so much of this story discussing, doesn't stay evenly distributed once that separation happens. It overwhelmingly follows the whey, leaving the solid curds behind with only a fraction of the lactose the original milk once contained. Think of it a little like sorting laundry, if that helps the picture stick. Lactose is dissolved in milk the way salt dissolves in water, spread evenly throughout the entire liquid. But once the proteins and fats clump together into curds that dissolved, sugar mostly stays behind in the liquid portion, rather than getting trapped inside the solid clumps themselves. Drain away the liquid, and you've drained away the majority of the problem right along with it, without anyone involved needing to understand a single word of the chemistry actually making that happen, which means that somewhere completely by accident, without a single person involved having the faintest idea why early herders had stumbled onto a genuine workaround for the exact biological limitation we spent an entire earlier part of tonight's story exploring. A way to take milk, something most adults on the planet at that point in history still couldn't properly digest and transform it into something a great many more of them actually could. Now, accidents happening once in one particular valley are interesting. Accidents happening reliably enough to leave behind solid physical evidence that survives thousands of years and eventually lands in front of modern researchers, are something else entirely. And that's exactly what happened in a region of Poland known today as Kujawia. Buried in the soil there, archaeologists uncovered fragments of unglazed pottery each one pierced through with dozens of small deliberate holes, unmistakably similar in shape to cheese strainers still used in some kitchens today. For years after their discovery, nobody could say for certain what these strange perforated vessels had actually been used for. Some researchers wondered if they'd been used to strain honey away from the comb. Others guessed they might have separated meat from broth while cooking. It took a careful chemical analysis examining fatty acid residues trapped deep inside the clay, itself residues that had survived quietly for thousands of years, to finally settle the question. Those fragments, dating back roughly 7,000 years, were soaked through with the unmistakable chemical signature of dairy fat. Not honey, not meat. Milk processed deliberately using tools built specifically for that exact purpose. That single discovery pushed back the earliest confirmed evidence of cheese-making in Europe by a considerable stretch, and it did something else just as important. It proved this wasn't some isolated one-time accident that happened to a single unlucky herder somewhere and was never repeated. Researchers eventually examined samples pulled from more than 30 separate vessels collected from that same region over the course of several decades of careful excavation, and found the same dairy signature turning up again and again. This was a technique, refined, repeated, deliberately built into pottery specifically shaped for the job. By the time these particular sieves were being used in Kuyavia, someone in that community already understood, even without any of the underlying science, that pouring milk through a perforated vessel, separating the solid from the liquid, produced something worth the extra effort. And Poland wasn't the only place this was happening either. Along the Dalmatian coast in what is now Croatia, researchers examining pottery from roughly the same broad era found a similar pattern, distinct vessel types, apparently associated with different stages of processing milk, from simple storage through straining to what increasingly looks like early cheese production. One style of pottery there carried the chemical signature of plain milk. Another, shaped differently, carried the signature of meat. A third, again shaped differently, still carried something that pointed unmistakably toward fermented dairy. In other words, these early communities weren't simply making cheese by trial and error each time. They had settled into a system, different tools built deliberately for different stages of the process, the sort of quiet specialization you only find once a technique has already been practiced for a good long while. Different regions, different pottery styles, similar underlying idea arrived at independently or spread through contact between communities we'll likely never be able to fully trace. Either way, the pattern is clear. This wasn't a fluke. It was a genuine spreading technology. Here's a thought worth sitting with for a second. We tend to imagine ancient people as somehow less capable than us, stumbling through history without any real understanding of the world around them. And yet here they were, thousands of years before anyone had the faintest concept of what an enzyme even was working out, through nothing but patient observation and trial and error, a solution to a biological problem modern scientists wouldn't fully explain for millennia. I find that quietly humbling every time I think about it properly. They didn't need a laboratory. They needed curiosity, a willingness to try the strange thing sitting in the bag instead of throwing it out, and enough seasons of practice to figure out how to do it on purpose instead of by accident. It's easy from where we're sitting tonight, comfortable and warm, to underestimate exactly how much careful observation that must have taken. Someone had to notice which pouches made from which animal curdled the milk fastest. Someone had to notice how long to wait, how warm the day needed to be, which batches turned out safe to eat and which ones didn't. None of that got written down anywhere, obviously, since writing itself was still thousands of years away in most of the world. It survived the only way anything could survive back then, passed from one set of hands to the next, parent to child, neighbour to neighbour, quietly refined a little further with each generation that bothered to keep paying attention. Let's be honest about one thing though before we get too romantic about it. That early cheese was almost certainly nothing close to what you might picture sitting on a nice cheese board today. No aging cellars, no specific cultures selected for flavour. Most of what these early communities were producing would have been closer to a simple, soft, fairly plain curd, not far off from something like a rough farmer's cheese you might still find today, made fresh and eaten within days rather than aged for months. Nobody in Kuyavia was pairing it with wine and calling it a delicacy. They were solving a very real, very practical problem. Everything fancy that came afterward, all the specific cultures, all the careful aging techniques, all the astonishing variety we take for granted now developed gradually over thousands of years on top of that first simple discovery. It's worth mentioning too that the story of ancient cheese doesn't end in Poland. Thousands of years after those first Kuyavian farmers were straining their own milk, halfway across the known world in a tomb belonging to a high-ranking official in ancient Egypt, archaeologists eventually uncovered something almost eerie. A broken jar and inside it a solidified whitish substance, roughly 3,200 years old. That laboratory analysis later confirmed was in fact an actual physical sample of cheese itself, not just chemical traces of one. It's worth drawing a clear distinction here because the two discoveries tell slightly different stories. Kuyavia gave us the earliest evidence of the technique, the process, the deliberate act of making cheese. That Egyptian tomb gave researchers something rarer still, an actual surviving piece of the cheese itself sealed away in the dark for over 3,000 years, waiting patiently to be found. Somewhere between those two discoveries sits an entire unbroken thread of human beings, across an enormous stretch of geography and time, all solving variations of the very same problem, usually without any idea that anyone else, anywhere else was working on it too. If you happen to be someone who deals with any trouble digesting regular milk yourself, here's something worth noticing about your own life tonight. Aged cheese and properly made yogurt tend to cause noticeably less trouble than a plain glass of milk, even for people whose bodies never picked up that genetic switch we spent so much time discussing earlier. The fermentation process, whether carried out by that ancient stomach enzyme or by the specific bacteria used in yogurt production, does a remarkable amount of the digestive work in advance, breaking lactose down before it ever reaches your own gut at all. Which means that somewhere in your refrigerator right now, sitting quietly on a shelf, there may be direct descendants of a discovery made completely by accident in a Neolithic farming settlement, thousands of years before anyone had a word for chemistry. Here's the detail that I find most remarkable about this entire chapter of the story, and it's worth carrying forward with you into what comes next tonight. All of this, the stomach pouches, the perforated pottery, the deliberate straining technique refined across entire communities, happened well over 1,000 years before that genetic switch we discussed earlier ever became common enough in the general population to matter on any meaningful scale. Culture solved this problem first. Human ingenuity, patient trial and error, generations of people willing to keep experimenting with something strange sitting in a stomach pouch, got there long before evolution itself managed to catch up, which raises an interesting question worth turning over in your own mind for a moment. If humans had already found a clever, reliable workaround for this exact problem through nothing more than pottery and patience, why would nature even bother finishing the job at all? Wouldn't a good enough cultural fix make a genetic one almost unnecessary? It's a fair question, and honestly, for a very long time it looks like nature agreed with you. This is where our story tonight takes a turn that surprised even the researchers who first went looking into it properly. You might expect that once a mutation this useful appeared anywhere in the human population, it would spread quickly, almost inevitably, the way a truly good idea tends to. That is not remotely what happened. Quite the opposite, in fact. Somewhere out there, quietly and visibly carried inside the bodies of a small handful of people, scattered across an enormous continent, that genetic switch we've spent so much time discussing was still out there too. Not thriving, not spreading quickly. If anything, for a very long stretch of this story, it was doing something closer to the opposite. Barely surviving at all, teetering right on the edge of vanishing from the human story completely in a handful of people whose names, like almost everyone else we've talked about tonight, history never bothered to record. That's exactly where we need to go looking next. Somewhere in the soil of modern-day Ukraine, buried for nearly 6,000 years, a set of human remains sat quietly waiting for a question nobody would think to ask for most of that time. Who was this person, and what, if anything, made their body different from everyone else buried anywhere near them? Getting an answer to that question is nowhere near as simple as it might sound. Genetic material breaks down over time, damaged by moisture, by heat, by thousands of years of ordinary chemistry working quietly away underground. Researchers who specialize in this kind of work usually have to go looking in oddly specific places. A dense little bone tucked deep inside the inner ear, or the root of a single tooth spots, where a bit of genetic material sometimes survives, the passage of centuries slightly better protected than everywhere else in the body. Even then, what comes out is often fragmented, tangled together with genetic traces left behind by soil bacteria and centuries of contamination requiring careful, patient laboratory work just to separate what actually belonged to that person from everything else that had crept in around them over the millennia. When researchers eventually extracted genetic material from those old bones and ran it through modern analysis, one particular detail stood out among everything else. This individual, a farmer living during a period archaeologists call the Neolithic, a transitional stretch of time when early metal tools were just beginning to appear alongside stone ones, carried a mixed genetic heritage part, descended from early farming communities, with roots stretching back toward Anatolia, part connected to herding people living far out on the grassy plains east of Europe, a group we'll be spending a great deal more time with shortly. And buried inside that mixed genetic background sat something else entirely. A single copy of the exact mutation we've spent so much of tonight's story exploring. As far as modern science has been able to determine through careful testing of ancient remains recovered from sites scattered right across the continent, this individual represents the earliest confirmed carrier of that mutation anyone has ever found. Somewhere around 5,960 years ago, in a single human body buried in what is now Ukraine. That tiny genetic switch we've talked about already existed, quietly doing its work completely unnoticed by anyone standing nearby. You would be forgiven hearing that for assuming the rest of this story writes itself. A useful trait appears, it spreads. Within a handful of generations, half the population carries it, and life simply continues on an upward inevitable climb toward the world we recognize today. There's something worth pausing on, actually, in the fact that this particular individual carried mixed ancestry at all parts settled, farmer part wandering herder, two very different ways of living folded together inside one single body, buried in one single grave. It's tempting, looking back with the benefit of thousands of years of hindsight, to treat that detail as some kind of foreshadowing, a hint of the bigger collision between these two worlds still waiting further down the road of our story tonight. Whether that connection means anything at all, or whether it's simply a coincidence dressed up nicely by a storyteller looking for meaning where none exists, is honestly hard to say with any certainty. Either way, it's a detail worth holding on to. That is almost exactly the opposite of what actually happened. Here's where our story tonight takes a turn that truly surprised the researchers who first went looking closely into the numbers. Fast forward roughly 1,000 years past that first known carrier in Ukraine into the period running from about 5,000 to 4,000 years ago, and take a proper look at how many people across Europe were actually carrying this supposedly game-changing mutation by then. Researchers examined genetic material recovered from 259 separate individuals, pulled from burial sites scattered across the continent during that exact window of time. Out of all 259 of them, only 3 carried the mutation at all. 3 out of 259. A frequency sitting right around 1% a full 1,000 years after the trait first appeared in the historical record we have access to. 1% after 1,000 years. Compare that just for a second with where this same trait eventually ended up. In parts of Northern Europe today, more than 9 out of every 10 adults carry some version of this ability comfortably. 9 out of 10 compared to roughly 1 out of every 100 1,000 years into the story. Whatever eventually happened between those two numbers, and we'll get to exactly that before tonight is over, it was not a quiet, steady climb. For a very long stretch, this trait was doing the exact opposite of thriving. It was barely hanging on. If you're the kind of person who enjoys sitting with a number like that for a moment, here's something worth noticing about it. 1,000 years is an enormous stretch of time by almost any measure that matters to a single human life. Roughly 40 generations, give or take, depending on how you count it. 40 separate generations of people living, working, raising children, passing down whatever they happened to carry inside their own bodies. And this particular trait still hadn't managed to reach even a fraction of the population in any meaningful way. So why the delay? Why didn't something this useful simply take over the moment it appeared? The honest answer involves a concept that tends to surprise people, who assume evolution works like some kind of steady, guaranteed march forward, always improving, always advancing in a straight line. It doesn't. Not even close. A huge amount of what determines whether a new trait survives at all has almost nothing to do with how useful it actually is, and everything to do with plain blind chance. If your picture of a helpful mutation looks anything like what movies and comic books have trained most of us to imagine, something dramatic, instant, sweeping through an entire population within a single generation, it's worth setting that image aside completely for tonight. Real evolutionary history rarely, if ever, works that way. There was no dramatic reveal here. No sudden transformation rippling outward across the continent. Just a small, quiet, fragile thread, easily broken, spending the better part of 1,000 years doing absolutely nothing remarkable at all. Here's a way to picture it that might help. Imagine holding a lottery ticket that gives you slightly better odds than everyone else standing around you. A genuine edge, not a huge one, but real. Now, imagine there are only a handful of drawings held before that ticket either gets passed along to someone new or simply disappears from the game, completely depending on who happens to have children, who doesn't, who survives a difficult winter, and who doesn't. Even with better odds, there's a very real chance your ticket just quietly vanishes early on, long before that small advantage ever gets the opportunity to properly show itself. Multiply that same uncertain gamble across dozens of separate carriers, spread out in tiny isolated pockets across an enormous continent. None of them aware the others even existed, and you start to understand exactly why this trait spent an entire 1,000 years barely holding on at all. Scientists have a proper name for this: genetic drift. Random chance quietly shaping which traits survive and which ones vanish, working alongside natural selection rather than being replaced by it. And in the earliest life of almost any new mutation, drift tends to matter enormously, more than most of us assume, simply because so few people carry the trait in the first place. One bad harvest, one difficult childbirth, One unlucky illness moving through a small settlement at exactly the wrong moment. Any one of those ordinary, unremarkable tragedies, the kind that struck ancient communities constantly, could have quietly erased this entire chapter of human history before it ever really began. There's another way to picture the same idea if the lottery comparison didn't quite land for you. Think of an incredibly hardy seed truly better equipped than most of its neighbours to survive drought or disease or a harsh season, scattered out across a wide, mostly rocky field. Being the best seed in the field doesn't count for much if it happens to land on bare stone instead of soil. Being the best seed only matters once it actually takes root, and out of dozens of equally promising seeds scattered across that same field, plenty of them through nothing more than bad positioning never get the chance to grow at all. This particular mutation spent 1,000 years scattered thinly across an enormous continent, landing here and there in isolated little patches of soil, most of them statistically speaking never destined to properly take root. This is worth sitting with honestly for a second because it corrects something most of us assume without ever really questioning it. We like to imagine useful traits as somehow protected, destined, guaranteed to succeed simply because they're helpful. Nature doesn't actually work that way. Being useful only ever grants a trait a slightly better chance of surviving long enough to matter. It never grants a guarantee. For a very long stretch of our story tonight, survival came down to nothing more dependable than luck repeated over and over, generation after generation in valley after valley, with absolutely no promise attached to any of it. And here's a sobering thought worth carrying with you for the rest of tonight's story. If this particular mutation, the one we happen to be following closely because it eventually succeeded, came this close to disappearing completely, how many other quietly useful mutations scattered across the whole of human history weren't quite so fortunate? How many small, promising genetic advantages appeared somewhere in someone at some point across the last few 100,000 years and simply vanished unnoticed, unrecorded, taking whatever potential they carried with them into nothing? We will never know most of their stories. We only get to hear about the rare handful that happened to survive long enough to leave a trace behind for us to eventually find. Think about what that actually means for you sitting here tonight capable of digesting milk without a second thought. Somewhere across roughly 40 separate generations spanning a full 1,000 years, every single person carrying that trait had to survive long enough to have children of their own. Every single one. A difficult birth gone wrong at the wrong moment anywhere along that chain, and this particular thread of the story simply stops permanently the way so many other equally promising threads almost certainly did, leaving behind no trace at all for anyone to ever find or wonder about. Have you ever stopped to consider how much of your own existence, not just this one trait we've spent tonight discussing, but nearly everything about who you are ultimately rests on an unbroken chain of ordinary people surviving ordinary dangers at exactly the right moments, purely by chance going back further than anyone could ever properly count? It's a strange thing to sit with late at night, comfortable and warm. Somewhere behind every one of us stretches an almost unbroken thread of luck. Try this thought for size too while we're sitting with it. Somewhere among your own countless ancestors stretching back far beyond anything written down anywhere, there is almost certainly at least one person who survived something they had no business surviving. A childhood illness that should have ended differently. A difficult season that should have gone the other way. None of us know their names, none of us ever will. But every single one of us is walking proof that they made it through anyway. I find something quietly moving about that, if I'm honest with you. Not the version of history most of us grew up picturing full of grand, inevitable forward progress, but something far more fragile, and if you ask me, far more remarkable, precisely because of how fragile it actually was. This particular trait wasn't destined for anything. It survived 1,000 years of near total obscurity purely because generation after generation, in a small enough handful of scattered households, somebody happened to live long enough and happened to have children who lived long enough to pass it along one more time. And here's the detail that makes this whole stretch of the story feel even more precarious once you sit with it properly. Among one particular group living during this exact period, herding animals across the wide-open grasslands stretching east of Europe, researchers went looking for this same mutation and came back completely empty-handed. Not one carrier found out of dozens of individuals tested from that community, which tells us something important heading into what comes next tonight. Whatever eventually changed the fate of this quiet, barely surviving mutation, it hadn't happened yet. Not among these particular people. Not during this particular stretch of our story. So there it sat for the better part of 1,000 years, carried by a small scattered handful of people across an entire continent, one unlucky winter away at almost any point along that stretch from disappearing from the human story altogether, taking your own ability to finish a glass of milk tonight, along with it into nothing. Ask yourself honestly for a moment whether you had ever pictured evolution working this way before tonight. Fragile, uncertain, riding on nothing sturdier than ordinary luck repeated quietly across generation after generation of people who had no idea any of this was even happening inside their own bodies. It's a very different picture from the confident, inevitable version most of us grew up with, and if you ask me, a far more honest one. But it didn't disappear. Somewhere quietly against odds that honestly should have swallowed it whole a dozen times over, it held on. And not long after this particular stretch of near silence, something did finally begin to shift dramatically, and surprisingly quickly once it actually started. Whatever changed, it did not come from within the small farming communities we've been following so closely tonight, quietly tending goats, straining curds, passing down half-understood rules about who could and couldn't safely drink milk. It came from somewhere else, entirely carried in on the backs of a people whose way of life looked almost nothing like the settled river valleys we've spent most of tonight's story inside. Entire new populations moving across enormous distances are about to walk directly into this story, and when they do, the numbers we've been discussing tonight are about to change in ways nobody carrying this fragile little mutation could possibly have predicted. That part of the story starts the moment we step off this quiet valley and onto the open grassland waiting just ahead. While that lonely little trait was struggling to survive, scattered thin across a handful of quiet farming villages, an entirely different way of life was quietly gathering momentum far to the east. Out across an ocean of grass, most of the people we've met so far in tonight's story would never have laid eyes on in their entire lives. Picture a landscape almost impossible to properly imagine if you've spent your whole life around cities or forests or coastlines. Grass stretching from horizon to horizon in every direction for thousands of miles, broken only occasionally by a slow-moving river or a low ridge of hills. This was the Pontic-Caspian steppe, vast belt of open land running roughly from what is now Ukraine, across southern Russia, and on toward Kazakhstan. And it was here roughly 5,000 years ago that a group of people archaeologists now call the Yamnaya built an entire way of life around a single radical idea. Instead of settling in one place and waiting for the land to provide, why not simply follow your herds wherever the grass happened to be growing best? The Yamnaya were not farmers in any sense the villagers from earlier in tonight's story would have recognized. They kept large herds of cattle and sheep, moving them across enormous distances with the seasons, and they had recently begun making serious use of two inventions that would end up reshaping the map of an entire continent. The wheel mounted onto sturdy wooden wagons capable of hauling tents, supplies and belongings across ground no farmer's cart had ever needed to cross before, and the horse tamed and ridden or harnessed to pull those same heavy wagons, turning what had once been an impossibly vast empty landscape into something a determined family could actually cross season after season, generation after generation. Try picturing the actual logistics of that lifestyle for a moment, because it's easy to romanticize and much harder to actually live. An entire household packed onto a wagon creaking across open grassland, herding animals that had opinions of their own about the whole arrangement, children, elders, and belongings, all making the same journey together with the nearest permanent shelter, sometimes weeks of travel away in any direction. There was no falling back on a neighbour's spare grain store during a rough season out there. Whatever your herd provided was quite literally the entire safety net standing between your family and disaster. Here's a fact worth sitting with for a moment because it says something about just how demanding that lifestyle actually was. Out on the open steppe, far from any river valley suited to farming, there simply wasn't much else to eat besides what your herd could provide. Meat, obviously, but meat alone is a surprisingly poor way to sustain a body across months of hard travel. Dairy filled that gap. Fresh milk when it was available, but far more often curdled, fermented, thickened into something closer to yogurt, or a soft portable cheese, exactly the kind of clever workaround we spent an entire earlier part of tonight discussing. For people constantly on the move, unable to carry heavy stores of grain or vegetables across a landscape that barely grew, either fermented dairy wasn't a luxury. It was closer to fuel, calorie-dense, reasonably durable, and crucially, thanks to that same fermentation trick, far gentler on a digestive system that for most of these travellers still hadn't picked up the genetic switch we've spent so much of tonight discussing. And these people did not simply stay put on their home stretch of grassland. Starting somewhere around 5,000 years ago, Yamnaya-related populations began moving, and moving is almost too gentle a word for what actually happened. Within a matter of centuries, genetic material connected to these steppe herders shows up scattered across an almost unbelievable stretch of territory, from Scandinavia in the northwest all the way to the Altai Mountains and even parts of Mongolia in the east. Stop and consider the actual distance involved in that eastward push for a moment, because it tends to get lost in a single sentence like the one I just gave you. Populations connected to these same steppe herders, a group researchers refer to as the Afana-Sievo culture, out on that eastern edge of the migration ended up herding animals thousands of miles from where their story on the Pontic-Caspian steppe first began closer to the edge of what is now China than to anywhere in Europe at all. Two branches of essentially the same people, one pushing west into the heart of Europe, another pushing east toward the edge of Asia, both carrying pieces of the very same genetic and cultural inheritance, quite possibly without either branch having any real awareness the other one existed at all. Entire populations thousands of miles apart carrying pieces of the same genetic story, the direct result of one group of highly mobile herders deciding generation after generation that the horizon was worth chasing. In parts of Europe, the impact of this migration was staggering. Populations archaeologists now refer to by names like the corded ware culture, spreading across much of Central and Northern Europe, carried genetic ancestry that was in some studied populations roughly 75% connected to these steppe newcomers. Another related group, the Bel-Beaker culture, particularly in its eastern branches, carried something closer to 50%. Researchers figured this out the same patient way they figured out nearly everything else we've discussed tonight, by comparing genetic material recovered from burial sites, dated before this migration against material recovered from sites, dated after it, layer by layer. Generation by generation, watching the underlying genetic signature shift in real time across the archaeological record. It's a bit like watching a photograph slowly develop, except instead of an image sharpening into focus, what emerges is an entire population's ancestry, visibly measurably changing shape within just a handful of centuries, which means that within a relatively short window of time measured in centuries rather than millennia, the genetic makeup of huge stretches of Europe shifted more dramatically than almost anywhere else in the entire human story before or since. In quite a few regions, the male lineages belonging to the original farming populations, the very same people whose villages and cheese strainers we spent time with earlier tonight, were almost entirely replaced within just a handful of generations. Now here's where this part of our story gets properly interesting, and honestly a little bit stranger than most tellings of it tend to admit, given everything we just discussed: the sweeping migrations, the dairy-dependent lifestyle, the sheer scale of genetic influence these steppe herders left behind across an entire continent. You would reasonably expect the Yamnaya themselves to have been carrying that lactase persistence mutation in fairly large numbers, spreading it outward along with everything else they brought with them. They mostly weren't. When researchers went looking directly inside the genetic material of actual Yamnaya individuals recovered from steppe burial sites, testing dozens of separate remains, they came back with something close to nothing. Almost none of the Yamnaya people tested carried the mutation at all. These were people whose entire way of life revolved around dairy, who depended on it for survival, across some of the harshest, most physically demanding migrations in the whole of human prehistory, and the overwhelming majority of them still could not properly digest fresh milk as adults, exactly the way nearly every human being before this point in our story couldn't either. Isn't that a strange thing to sit with for a second? An entire civilization, arguably one of the most dairy-dependent cultures in the whole of human history, up to that point built almost entirely around an ingredient most of its own people's bodies technically weren't equipped to handle in its raw form, which tells you something important about just how good their fermentation techniques must have actually been. They didn't need the genetic shortcut. They had already engineered their way around the problem generation after generation, the same clever workaround we discussed earlier, just adapted for a life spent constantly on the move rather than settle beside a river. It's worth pausing on the sheer discipline that must have taken too. Every single day on every single leg of that journey, someone in each travelling household had to know exactly how long to let milk sit, exactly how it needed to be handled, exactly which batch was safe, and which one wasn't, all without a single written recipe to check against, and all while simultaneously managing a herd, a family and a wagon rattling across unfamiliar ground. That kind of inherited practical knowledge rarely gets remembered by name in history books. It deserves a little more credit than it usually gets. So if the Yamnaya themselves weren't the ones carrying this trait in any significant numbers, where does that leave the story? This is honestly one of the genuine open questions researchers in this field are still actively working through. And I think it's worth being upfront about that rather than pretending the science is more settled than it actually is. One line of thinking holds that the mutation may have originated somewhere among the descendants of those earlier European farming communities we spent time with a while back, quietly present in small numbers long before any steppe herder ever set foot on the continent, and that the enormous population movements of this era simply mixed existing carriers into new communities faster and more widely than anything that had come before. Another line of thinking points toward ancestry connected even further east and further back, suggesting the mutation, or at least the genetic background. Carrying it may have older, deeper roots tracing back toward populations that contributed to the steppe herders themselves, even if the Yamnaya samples so far mostly don't show it directly. Researchers studying ancient genetic material continue testing new burial sites in new regions, hoping each new sample will finally settle the question with a bit more certainty. What we can say with real confidence is this: Whatever the exact origin turns out to be something about this particular period, this exact churning, migrating, mixing moment in human history mattered enormously. Populations that had spent thousands of years living in relative isolation from one another, quietly developing their own local habits, their own local genetic quirks, suddenly found themselves neighbours, intermarrying, trading, sharing meals, and yes, sharing genetic material on a scale the earlier chapters of our story simply hadn't allowed for. Here's a question worth turning over while we sit with all this uncertainty together. Do you think a clear, tidy answer to a mystery like this one would actually feel more satisfying than the messy, unresolved version we just walked through? Or is there something you find more honestly compelling about a piece of history that real experts are still actively arguing over right now this year, rather than something settled and filed away in a textbook decades ago? Have you ever noticed how often major turning points in history come from exactly this kind of unglamorous mixing, rather than any single dramatic moment anyone could point to and call the cause? We like our history tidy. One invention, one battle, one discovery, one clear line from cause to effect. Actual history rarely cooperates with that preference. More often it looks like this instead. Different groups of people carrying different pieces of a puzzle, none of them could see the full shape of colliding across a couple of centuries, and something new, quietly emerging from all that overlap without anyone involved fully understanding at the time what exactly they were setting in motion. I'll admit there's something almost humbling about how much of this particular chapter still isn't fully settled. It would be tidier as a storyteller to hand you one clean, confident answer about exactly where this trait came from and exactly how it travelled. But real science, the kind actually being done in laboratories and excavation sites right now, doesn't always offer that kind of tidiness, and I'd rather sit honestly with the uncertainty than pretend otherwise just to wrap this part of the story up neatly. What we do know with real confidence is what happened to the raw numbers during this period. Remember that lonely 1% we spent so much time on a little earlier tonight, carried by only a handful of scattered farmers across an entire continent for the better part of 1,000 years. By the time these steppe migrations had run their course, that number had started climbing slowly at first, then with increasing speed as centuries passed and generations mixed. The lonely, fragile thread hadn't just survived. It had finally, after 1,000 years of near silence, found room to grow. Sit with that turnaround for a moment, because it's worth appreciating properly before we move any further. A trait that spent a full 1,000 years hovering at around 1%, one unlucky season, away from disappearing completely more times than anyone could count, was within a handful of centuries on its way toward becoming one of the most successful single genetic changes in the entire story of our species. Not because the trait itself had changed in any way. The exact same single swapped letter, doing the exact same quiet job it had always done. What changed was the world around it mixing, shifting, throwing far more opportunities its way than it had ever had access to before. But here's the piece of this puzzle that still leaves a rather large question sitting unanswered, and it's worth carrying forward with you into what comes next tonight. None of what we just discussed actually explains why this trait was worth favouring so strongly in the first place. If humans had already solved the practical problem of digesting dairy through fermentation patiently, effectively, for well over 1,000 years before any of this migration even began, why would a body actually need this genetic shortcut at all? What real advantage could it possibly offer someone who already had perfectly good cheese sitting in their own kitchen? For a very long time, scientists thought they had a fairly confident answer to exactly that question. It felt obvious, almost too obvious, to seriously question. And as it turns out, that comfortable, widely accepted answer was almost entirely wrong. That's exactly the mystery we need to untangle next. Here's what most people assume the moment they first hear this entire story laid out. Milk provided extra nutrition, extra calories, extra calcium for building strong bones in places where sunlight was scarce for half the year. People who could digest it comfortably simply got a small, steady health advantage over everyone around them. Healthier children, more of those children surviving into adulthood. Generation after generation, that tiny nutritional edge compounded until eventually the trait became common. It's a tidy explanation. It makes intuitive sense. It fits neatly into the kind of story we like to tell about evolution, rewarding the fittest, the strongest, the best fed. For decades, that was almost exactly what serious researchers believed too, printed confidently in textbooks, repeated in documentaries, taught to students who went on to repeat it themselves without much reason to question it. It turns out to be almost entirely wrong. Before we take it apart, let me ask you something honestly. If I had asked you before tonight why you think you're able to drink milk comfortably, what would you have guessed? My own honest answer. The first time I properly looked into this story would have been something close to that same tidy nutrition explanation. It simply feels right. It fits the shape evolution stories usually take in our heads, a steady climb toward advantage, healthier winning out over less healthy generation after patient generation, which makes what actually happened all the more worth sitting with properly. Let's actually sit with the traditional explanation for a moment before we take it apart properly, because it deserves a fair hearing rather than a quick dismissal. The idea in its full form usually pointed toward calcium specifically. In parts of the world sitting further from the equator, sunlight, which your skin needs in order to produce enough vitamin D to properly absorb calcium, becomes scarce for large stretches of the year. Milk happens to be naturally rich in calcium. String those two facts together and you get a fairly compelling story. People living through long, dim winters who could actually digest milk properly would have had an edge building strong bones, and avoiding certain deficiencies and edge, that generation after generation quietly nudged the trait toward becoming more common across exactly the populations where that pressure would have mattered most. It's a good story. It even matches roughly where lactase persistence ended up being most common today. The trouble is, a good story matching where things ended up isn't the same thing as actual proof of how they got there. And once researchers finally had the tools and the data to properly test that assumption, it started falling apart almost immediately. There's something almost funny about how long this particular version stuck around if you think about it. Generations of students sat through lectures repeating this exact calcium and sunlight explanation with complete confidence. Professors included, textbook authors included, all of it sounding perfectly reasonable. All of it repeated forward without anyone actually running the numbers properly until relatively recently. It's a useful reminder that a story sounding logical and a story being true are unfortunately not always the same thing, no matter how many confident people repeat it in the meantime. A team of researchers based in Britain set out not long ago to settle this question properly once and for all, using an approach nobody had ever been able to attempt at this scale before. Rather than relying on guesswork or assumption, they built an enormous database examining chemical residues left behind in ancient pottery. Close to 7,000 separate samples of preserved animal fat, extracted from more than 13,000 individual pottery fragments, recovered from over 500 archaeological sites scattered across the whole of Europe. Taken together, that collection of evidence stretched across roughly 9,000 years of prehistory, offering something nobody had ever properly had access to before. An actual detailed region-by-region map of exactly when and where people across ancient Europe were using milk and how heavily they relied on it century after century. Try picturing the sheer scale of that undertaking for a moment. 13,000 individual fragments of broken pottery, most of them smaller than your own hand, each one requiring careful laboratory analysis just to detect traces of fat too faint for the naked eye to notice chemically preserved inside clay for thousands of years. That's not the work of a single afternoon in a laboratory. That's years, likely decades, if you count everyone who contributed pieces of that puzzle before the final picture came together, spent patiently building toward one clear answer to a question that had gone unresolved for far too long. What they found first confirmed something we've already spent quite a bit of tonight's story exploring. Milk use really was widespread and really did stretch back to the very earliest days of farming in Europe, just as we discussed earlier. But the details buried inside that map held a genuine surprise, one that would end up quietly overturning decades of assumption. If the traditional explanation were correct, you would expect a fairly clear pattern to show up in all that data. Regions where people relied more heavily on milk drank it more often, in greater quantities, should show the trait spreading faster and becoming more common sooner than regions where milk played a smaller role in daily life. That correlation should have been the whole foundation the traditional theory rested on. It wasn't there. The researchers looked carefully, rigorously, region by region, century by century, and found no meaningful relationship at all between how much milk a population actually consumed and how quickly that population picked up the genetic trait, allowing them to digest it comfortably. Places drinking enormous amounts of milk showed no particular rush toward developing the mutation. Places drinking comparatively little sometimes showed just as much genetic change as anywhere else. Whatever was actually driving this trait toward becoming common, it wasn't simply a matter of more milk equaling more advantage equaling faster spread. Here's a second piece of evidence that quietly finished off what remained of the traditional explanation. Researchers examined health data collected from several 100,000 living adults today, comparing people who carry the genetic trait against people who don't, looking specifically at whether those without it actually suffer any measurable long-term health consequences from drinking milk regularly anyway. The answer, it turns out, is mostly no. Most people who technically cannot properly digest lactose and who drink milk, regardless, experience nothing worse than occasional discomfort. No dramatic nutritional deficiency, no measurable disadvantage stretching across an entire lifetime, at least under the ordinary, reasonably well-fed conditions most of these participants were living under. Think about how strange that finding actually is once you sit with it properly. Hundreds of thousands of modern adults going about entirely normal lives, and the ones lacking this supposedly crucial genetic advantage are by and large perfectly fine, not thriving less, not measurably worse off in any way researchers could pin down, which quietly undermines the entire foundation the nutrition-based explanation had been resting on for decades. If lacking this trait carries so little real cost today, under comfortable modern conditions, it becomes very hard to argue that a small nutritional edge alone could have driven this trait from a lonely handful of carriers all the way to dominance across entire populations, which raises an obvious, slightly uncomfortable question. If drinking milk without the mutation isn't actually all that costly under normal circumstances, what exactly was creating enough evolutionary pressure to push this trait from a lonely 1% all the way toward dominance across entire populations? The answer researchers eventually settled on is considerably darker than the tidy nutritional story most of us grew up hearing, and it's worth sitting with honestly rather than softening. Under ordinary healthy conditions, drinking milk without the ability to properly digest it causes exactly what we've already discussed earlier tonight: cramping, bloating, an uncomfortable night followed by a completely normal morning. Unpleasant certainly, but rarely dangerous for someone otherwise healthy and well-fed. But prehistoric life, especially during the periods when this trait was finally beginning, its real climb toward common, was very rarely gentle enough to guarantee anyone stayed healthy and well-fed for long. Famine arrived in waves tied to failed harvests, harsh winters, and the simple bad luck of trying to feed a growing population off land that couldn't always keep up. Disease moved through denser, more crowded settlements with increasing regularity as populations grew, and people lived closer together, closer to their animals, closer to each other's waste and illness than farming communities ever had before. It's worth remembering, too, everything we already learned earlier tonight about exactly this period. Growing populations, denser settlements, herds of animals now living in far closer daily contact with people than at any earlier point in this entire story. Every single one of those conditions, the very same conditions that made this era such a turning point for migration and mixing, also happen to be precisely the conditions under which disease spreads fastest, and famine, when it finally arrives, does the most damage to the people already living closest to the edge. Here's where the real danger hides the piece that changes this entire story. For a healthy adult, drinking milk their body can't properly digest is an inconvenience. For someone already weakened by hunger, or already fighting off illness, that same reaction, the cramping, the diarrhea, the fluid loss, stops being merely uncomfortable and starts becoming truly dangerous. Severe dehydration on top of existing malnutrition or infection can be the difference between recovering and not recovering at all. And during a famine, specifically desperate people reach for whatever food happens to be available, milk included, regardless of whether their own body can safely handle it, precisely because the alternative sitting in front of them is simply going hungry. Which means the real advantage this mutation offered may not have been extra nutrition during the good years at all. It may have been survival specifically during the very worst ones. Not a reward handed out for thriving, a shield quietly protecting the people who happened to carry it during exactly the moments everyone around them was most vulnerable. Take a second and sit with that if you're willing to. The traditional story lets us imagine this trait spreading through something like gentle, steady progress, healthier children slowly outnumbering everyone else over the centuries. The updated picture looks considerably more brutal. This trait very likely spread at least in significant part because the people who lacked it were dying disproportionately during exactly the crisis moments when a community's population was already under the most strain. Nature in this particular telling of the story wasn't quietly rewarding an advantage. It was quietly punishing an absence over and over, generation after generation, until the people carrying that absence simply stopped being as common as everyone else. How does that sit with you? Honestly, most of us grow up picturing evolution as a story about winners, the strongest, the smartest, the best, adapted, quietly rising to the top. How differently would we tell these kinds of stories, do you think, if we started from the more uncomfortable truth that survival an awful lot of the time throughout human history had far less to do with anyone winning anything, and far more to do with who simply didn't lose? Researchers tested this idea properly rather than simply proposing it, and moving on using population size fluctuations recorded in the archaeological record as a rough proxy for how often and how severely famine likely struck a given region, and using settlement density as a rough proxy for how much disease exposure a population likely faced. Both factors tested independently lined up closely with exactly where and when this genetic trait shows the clearest signs of being strongly favoured. Not milk consumption on its own. Crisis, population stress. The kind of hardship that turns an everyday inconvenience into a matter of life and death. Does that reframe anything for you, thinking back over everything we've covered so far tonight? We spent real time earlier admiring the cleverness of cheese, making the patient ingenuity of early dairy farmers slowly working out how to make milk safer for everyone around them. That part of the story still absolutely holds up, and honestly I don't think it should be diminished by what we just learned. But underneath all that cleverness running quietly the entire time sat a far harsher current, one made of failed harvests and sickness moving through crowded settlements, and countless nameless people whose bodies simply couldn't survive what everyone else around them somehow managed to. I'll be honest with you. Of everything we've covered tonight, this particular piece of the story is the one I find hardest to sit with comfortably, and I don't think that discomfort is something worth smoothing over, just to keep things pleasant before bed. Evolution doesn't consult anyone's feelings before deciding what survives. It simply keeps score generation after generation, and the people whose bodies happen to match whatever the moment demanded are the only ones who ever get to pass anything forward at all. It's worth saying plainly too that this newer explanation, however well supported by the evidence, still represents our current best understanding rather than some final, unchangeable answer. Science works exactly this way, and honestly that's precisely what makes it trustworthy rather than despite it. The nutrition-based story felt sensible for decades, right up until someone finally built a large enough, careful enough body of evidence to properly test it. This famine and disease-based story may hold up for decades more, or it may itself eventually be refined or partly overturned by researchers not yet born working with tools we can't currently imagine. That uncertainty isn't a weakness in the story. It's simply what honest science actually looks like while it's still being figured out in real time. So if this particular pressure famine crowding disease only really applied to the story we've been following across Europe tonight, a fair question naturally follows. Did anywhere else on Earth face anything similar? And if they did human bodies anywhere else on the planet arrive at a solution? Anything like the one we've spent this entire story exploring? Or did they perhaps find their own separate path to the very same destination entirely on their own, with no idea any of this was happening on the far side of the world? That's the mystery waiting for us on the other side of the world. The answer to that question, as it turns out, takes us somewhere our story hasn't been yet tonight, and it arrives with a twist most people never see coming, the first time they hear this properly explained. For a long while, researchers assumed the story we've been following all night. The one single swapped letter sitting quietly upstream from a lactase gene in European populations was simply the story. The one lucky mutation and the one lucky continent spreading outward from there. It made a certain kind of sense. Why would something this specific, this precise happen more than once anywhere on Earth? Evolution, after all, doesn't exactly hand out second chances at the exact same lottery, or so the thinking went for quite some time. Then researchers started testing pastoralist communities living far from Europe, entirely deep in East Africa, and the results made absolutely no sense at all, at least not at first. Populations herding cattle across the dry hills of Sudan and the wide grasslands of Kenya and Tanzania showed exactly the pattern you'd expect if this same European mutation had somehow travelled there. Large numbers of adults comfortably digesting milk their entire lives, generation after generation, clearly leaning on dairy as a central part of daily survival. Researchers went looking for that familiar genetic switch, the one we've spent so much of tonight getting to know closely. It wasn't there. Let's sit with that for a second, because it's a truly strange finding once you understand exactly what it means. Here were entire populations capable of digesting milk into adulthood just as comfortably as anyone in Northern Europe, and yet when researchers examined their genetic material closely, the actual mutation responsible looked nothing like the one we've followed across an entire continent tonight. Different letter. Different position, a completely separate, unrelated change sitting in roughly the same general neighbourhood of the genetic instructions controlling that same lactase gene, but arrived at through an entirely independent route. Nature, it turns out, did not solve this particular problem once. It solved it at least 5 separate times in at least 5 different populations on at least 3 different continents, none of whom had any contact with one another, none of whom could possibly have shared the answer between them. There's something almost comical about that if you allow yourself to smile at it for a second before we get back to being properly serious. Picture evolution as an engineer without a memory stumbling onto the exact same clever fix over and over in completely different workshops on completely different continents, never once realizing another team somewhere else had already solved the identical problem centuries earlier. Nature does not send memos. It simply keeps encountering the same pressure wherever people happen to build a life around milk closely enough, and keeps landing on some version of the same answer, purely because the underlying problem itself never really changes, no matter which corner of the planet it happens to show up in. Scientists have a name for this kind of pattern, and it's worth understanding properly because it says something remarkable about how evolution actually operates. Convergent evolution. Different starting points, completely unrelated changes arriving independently at strikingly similar solutions simply because the underlying pressure pushing toward that solution happened to be strong enough and consistent enough that more than one population working with entirely different genetic material eventually stumbled onto some version of the same answer. Think of it less like one lucky architect drawing up a single blueprint copied everywhere afterward, and more like several completely separate engineering teams working in isolation on different continents, with no knowledge of each other's progress, all independently arriving at roughly the same working solution to roughly the same problem. You see this same basic pattern show up elsewhere across the natural world too if you go looking for it. Wings evolved separately in insects, in birds, and in bats, 3 completely unrelated solutions to the same basic problem of getting off the ground. Eyes evolved independently dozens of separate times across the history of life on this planet, in creatures that share no direct evolutionary connection to each other whatsoever. Our own small, quiet story about milk and genetics tonight turns out to belong to a much larger, much older pattern, one that keeps repeating itself throughout the entire history of life. Whenever a problem proves important enough and solvable enough for more than one branch of the tree to stumble onto some version of the answer independently, one of the clearest examples belongs to a population called the Bayer pastoralist herders, living across the Red Sea hills of Sudan, moving their animals through some of the driest, most demanding terrain anywhere on the continent. When researchers tested for lactase persistence among the Bayer, the number that came back was striking. Somewhere close to 88% of the population tested carried the ability to digest milk comfortably into adulthood, a rate rivaling or exceeding what you'd find in parts of Northern Europe. Now hold that number next to a very different one from a very different kind of community tested during that same broader research effort. The Sandaway, a group of hunter-gatherers living in Tanzania following an entirely different way of life, one that never depended on herding animals for milk at all. Among the Sandaway researchers found lactase persistence in roughly 26% of those tested, a dramatically lower figure. Same general region of Africa, wildly different outcome, and the difference lines up almost perfectly with the one factor that mattered most across this entire story tonight, whether or not a population actually depended on milk for survival generation after generation, closely enough for that dependence to leave a lasting mark on their genetic material. Have you noticed by now how consistently that same pattern keeps showing up, no matter where on earth we happen to look tonight? It's almost eerie, honestly, watching the exact same underlying logic play out again and again in populations who never once crossed paths with each other. who spoke entirely different languages, who had no shared history connecting them in any direct way at all. It's worth pointing out too just how physically demanding the Bayer way of life actually is, since it makes the whole story land with a bit more weight. The Red Sea Hills aren't gentle country. Herders there move their animals across some of the harshest, driest terrain found anywhere in the region, relying on those same animals not as an occasional treat, but as the backbone of daily survival year after year in conditions where a failed season could mean genuine hardship for an entire family. Under exactly that kind of sustained, unforgiving pressure, the same pattern we watched unfold slowly across Europe earlier tonight seems to have played out again on its own timeline, with its own genetic solution arriving at roughly the same destination anyway. The specific mutation carried by many Bayer individuals appears to be closely related to a variant researchers believe likely originated somewhere in the Sudan region itself, later carried outward by herding communities, speaking a family of languages linguists call Proto-Southern Cushitic, moving south into what is now Kenya. Archaeological evidence recovered near Lake Turkana, showing some of the earliest confirmed livestock remains anywhere in East Africa, dates that particular movement to somewhere between 4,300 and 5,000 years ago, a timeline that fits remarkably well alongside everything else we've discussed tonight about how closely dairying and genetic change tend to travel together wherever on Earth that particular partnership happens to take root. And Africa wasn't finished revealing surprises either. Travel further east across the Red Sea into the Arabian Peninsula, and researchers studying pastoralist families in Saudi Arabia found yet another completely separate mutation, again controlling that same general region near the lactase gene again arrived at, through its own entirely independent path unconnected to either the European or the African versions we've just discussed. A third continent, a third unrelated solution. The same underlying evolutionary problem solved yet again by yet another population with no meaningful contact with either of the other two. Here's a detail that might be my favourite piece of this entire chapter of the story, and it involves a twist I didn't see coming myself the first time I looked into it properly. Travel further still into parts of India among certain communities who have herded cattle for countless generations, and you find something different from what you might expect. Not a fourth entirely separate mutation, the exact same one we've been following since the very beginning of tonight's story, the identical European variant showing up in populations thousands of miles away, with no obvious reason to share it unless you remember something we spent real time discussing a little earlier tonight. Those enormous sweeping migrations out of the grasslands east of Europe didn't stop conveniently at the edge of the continent for the sake of a tidy story. Some of those same migratory threads reached much further deep into South Asia, carrying pieces of shared ancestry, and apparently, in at least some populations, this exact genetic trait along with them. Think about the sheer distance folded into that single fact for a moment. Two populations, one tending cattle across the hills and valleys of Europe, another tending cattle across a completely different landscape, thousands of miles to the east, sharing not just a general strategy for surviving off dairy, but the precise identical genetic mutation, down to the exact same swapped letter we spent so long getting familiar with earlier tonight. Not a coincidence arrived at separately, an actual shared inheritance carried forward by people whose ancestors once stood quite possibly in roughly the same stretch of grassland before their descendants scattered in entirely different directions across an entire continent and beyond. It's a strange, quietly moving thought if you let yourself sit with it. A single tiny genetic change first appearing somewhere in a farming valley we spent time in earlier tonight, eventually showing up entirely through ordinary human movement and mixing rather than any grand design, in communities living thousands of miles away, herding entirely different breeds of cattle, speaking entirely different languages, following entirely different customs, united by nothing more than one shared thread buried invisibly inside their own bodies. There's one more thread worth following before we move on, because it adds yet another layer to how tangled this whole story actually gets. In parts of southern Africa, among certain Kho-speaking pastoralist communities, researchers found traces of that same African variant we discussed a moment ago, the one most closely associated with populations far to the north and east. Genetic evidence suggests it likely arrived through direct contact and intermarriage with herders migrating down from East Africa, carrying both their animals and quietly their genetic inheritance southward, across an enormous stretch of the continent, blending with local hunter-gatherer populations who had lived in that region for tens of thousands of years before any herder ever arrived. What makes this particular thread so interesting is what it reveals about the deeper layers hiding underneath a single population's genetic story. Modern communities in this part of southern Africa carry a blend of ancestry, part connected to hunter-gatherer groups who called this land home since long before farming existed anywhere on Earth, part connected to herders whose own journey traces back toward the very same East African communities we spent time with a moment ago. Even within one single region, one single population, this story keeps folding back on itself, layer after layer, migration after migration, each one leaving its own quiet genetic fingerprint behind for researchers to eventually untangle piece by careful piece. Sit with the full shape of this story for a moment, all of it laid out together. Europe, Sudan, Kenya, Tanzania, Saudi Arabia, India, Southern Africa. At least 5 separate genetic solutions to the exact same biological puzzle, arising independently in populations separated by oceans, deserts, and thousands of years, none of whom had any way of knowing the others existed, let alone that they were quietly working toward the very same answer. I find something almost humbling in that, honestly, more than almost anything else we've covered across this whole story tonight. It would be easy, focusing only on the European chapter of this tale, to walk away thinking this was somehow a uniquely European story, one lucky continent stumbling onto something nobody else managed. The truth turns out to be considerably richer, and honestly a great deal more human than that. Wherever people anywhere on this planet built a life closely enough around herding animals, closely enough around milk for that dependence to matter, across enough generations, something in the underlying biology of our species responded independently repeatedly, as though the pressure itself simply refused to be ignored no matter which continent it happened to land on. It's worth remembering too that every single one of these populations in Sudan, in Kenya, in Arabia, in India, in southern Africa, arrived at their own version of this story, through their own particular hardships, their own particular ingenuity, without a single shred of help or inspiration borrowed from anywhere else. Nobody was copying anybody. Nobody even knew the others existed, which makes the fact that they all arrived somewhere so similar feel less like coincidence and more like something closer to inevitability dressed up differently depending on where in the world you happen to be standing when it finally caught up with you. Which raises a fair question worth carrying forward with you. If nature solved this same problem so many separate times in so many separate places, does that tell us this particular challenge? Digesting milk safely into adulthood was simply one of the most powerful, most consistent evolutionary pressures our entire species has faced in the last 10,000 years. I think it does. And I think that says something worth remembering next time somebody tries to tell you a single tidy story about where any major human trait actually came from. Biology again and again tonight has turned out to be far messier, far more repetitive, and honestly far more interesting than any single clean narrative could ever properly capture, all of which leaves us with an enormous, uneven, wonderfully complicated map. Different mutations arriving at different times, spreading to different degrees, leaving the modern world with a strikingly strange patchwork of who can comfortably finish a glass of milk tonight and who absolutely cannot. A patchwork that has almost nothing to do with where someone happens to live today, and everything to do with choices their ancestors made or never got the chance to make thousands of years ago. That patchwork and exactly what it looks like today across the very countries most of you watching this are sitting in right now is worth pulling apart properly before this story goes any further. This part of the story comes home now literally to whatever country most of you listening tonight happen to be sitting in right now, because everything we've covered so far isn't just ancient history sitting quietly in a museum somewhere. It's still shaping real dinner tables, real digestive systems, real family arguments about whether cousin so-and-so is just being dramatic about ice cream tonight in your own city, whether you've ever thought about it in these terms before or not. Picture your own last holiday gathering for a moment, everyone crowded around one table, sharing the exact same dishes, the exact same pitcher of milk passed from hand to hand. Somewhere at that table almost certainly sat people whose bodies were about to respond to that shared meal in completely different ways, and not one of them likely gave it a second thought at the time. That quiet, invisible variation sitting at your own table is the direct living continuation of everything we've spent tonight exploring. Here's the honest sweeping shape of where this entire story actually landed. Right now, across the whole of humanity, somewhere close to 2 out of every 3 adults on this planet cannot fully digest lactose the way a nursing infant can. Roughly 65%, give or take, depending on exactly which study you're looking at and how it was measured. Which means if you're one of the people who can finish a glass of milk tonight without a second thought, you're on a global scale part of a genuine minority. A fairly large minority in some regions granted, but a minority nonetheless once you zoom all the way out and look at our species as a whole. That number, though, hides an enormous amount of variation underneath it, and the shape of that variation traces almost perfectly the exact map we've been drawing together across this entire story tonight. In parts of Northern Europe, the numbers flip almost completely. Somewhere between 5 and 15% of adults struggle with lactose there, meaning the overwhelming majority in places like Denmark or the Netherlands or Sweden carry some version of that mutation we've spent so much of tonight tracing back to its origins. This is the end point of the story we followed earlier. The quiet farming villages, the near extinction 1,000 years in the steppe migrations finally pushing the numbers upward. This is what that whole journey eventually produced written directly into the bodies of an entire region today. Travel east into large parts of East Asia, and the picture reverses almost entirely. In China, in Japan, in Korea, and across much of Southeast Asia, lactose intolerance affects the overwhelming majority of adults, frequently cited at somewhere above 90% in the research literature. Dairy farming historically simply never became a central part of the food culture across most of this enormous region, the way it did in Europe or parts of Africa, and the underlying biology followed exactly the pattern you'd expect once you understand everything we've discussed tonight. No sustained selective pressure toward digesting milk into adulthood, no meaningful spread of any mutation capable of producing it. Elsewhere across the globe, the picture settles somewhere in between those two extremes, and honestly, that middle ground tells its own quiet story too. Across much of the Middle East, researchers have documented lactose intolerance rates, somewhere around 70% a region carrying its own separate independent mutation. We spent time with a little earlier tonight present in a meaningful minority, but never quite reaching the dominance it eventually achieved further north. Across Latin America, figures tend to hover somewhere closer to 50%, reflecting an intricate layered blend of indigenous European and African ancestry, all folded together within the very same populations, each thread carrying its own separate genetic inheritance from tonight's story. Here's a piece of this puzzle that deserves particular care and attention because it connects directly back to the very beginning of our story tonight in a way I find quietly moving every time I sit with it properly. Among indigenous communities across the Americas from the Arctic down through Central and South America, lactose intolerance affects close to the entire adult population, frequently cited above 95% in some communities close to universal. Why there specifically? The answer traces back to timing, and it's worth understanding properly rather than just accepting the number on its own. The ancestors of indigenous peoples across the Americas crossed into this hemisphere many thousands of years before any of the events we spent tonight's earlier chapters exploring had even begun. Long before anyone in the Fertile Crescent looked twice at a wild goat and wondered about keeping it close. Long before a single stomach pouch anywhere accidentally curdled into something resembling cheese. The entire domestication story we walk through together tonight, the herds, the milking, the fermentation, the slow genetic response to all of it simply hadn't happened yet anywhere on Earth. By the time these populations had already settled an entirely separate hemisphere, developing their remarkable agricultural traditions around crops rather than dairy animals. There was no domesticated cow, goat or sheep anywhere in the Americas prior to European contact. No dairying tradition to create the exact pressure we've spent this whole story exploring, which means biologically speaking, these populations never had the opportunity to be shaped by a pressure that from their perspective quite literally hadn't been invented yet. Sit with that for a second because it reframes something worth reframing. This isn't a story about one population being somehow behind another. It's a story about one enormous chapter of human history, the entire dairy chapter we've spent tonight exploring in such detail playing out exclusively on one side of the planet, while an entirely different set of populations on an entirely different continent were busy writing their own separate, equally sophisticated story built around entirely different foundations. It's worth remembering too, everything these populations accomplished instead on their own separate timeline, with their own separate set of tools available to them. Civilizations across the Americas independently domesticated crops like maize and potatoes, and countless other plants still feeding a huge portion of the world's population. Today built sophisticated agricultural systems supporting enormous cities entirely without ever needing a dairy animal anywhere in the picture. The absence of one particular chapter, the milk chapter we've spent all night following so closely, says nothing at all about capability or ingenuity or sophistication. It simply says the specific challenge we've been tracing tonight never happened across their particular path, the same way plenty of challenges facing European farmers never once crossed the path of the brilliant agricultural civilizations flourishing across the Americas during those same centuries. Now let's bring this closer to home still, because the numbers get remarkably striking once you look at any single country carrying multiple ancestral threads woven together at once. Within the United States specifically, researchers found roughly 15% of white Americans of Northern European descent report lactose intolerance, a number that lines up closely with what we'd expect given everything discussed tonight. Among Mexican Americans, that figure climbs to somewhere around 50%. Among African Americans, closer to 80%. Among Asian Americans, frequently cited above 80% as well. Think about what that actually means practically inside a single country, a single school system, a single extended family gathering around one dinner table for a holiday meal. Wildly different bodies all sitting at the same table, all handed the same glass of milk, responding in completely different ways, not because of anything anyone chose or ate wrong, or failed to build up a tolerance for through sheer effort, but because of thousands of years of separate ancestral history, quietly written into each person's own genetic material long before they were ever born. Imagine two children best friends growing up 2 doors down from each other, on the very same street, eating lunch at the very same school cafeteria table every single day. One of them finishes a full carton of milk without a second thought and asks for another. The other spends the rest of recess quietly uncomfortable, and probably has no idea why, and likely never once considers that the answer traces all the way back, through steppe herders and Neolithic cheese strainers, and a single swapped genetic letter, first appearing in a farming valley thousands of years before either of their families ever existed. Neither child did anything wrong. Neither body is broken. They are simply carrying 2 entirely different, equally valid inheritances sitting side by side at the same lunch table, without either of them ever knowing it. Here's where this part of the story intersects with something a little more uncomfortable, and I think it's worth mentioning honestly rather than skating past it. For a good stretch of the 20th century, public nutrition guidance across parts of the world, including large-scale school meal programs, leaned heavily on dairy as a primary, almost default source of protein and calcium for growing children. That guidance, well-intentioned as it generally was built largely around the dietary patterns and biology of populations with high rates of lactase persistence, without fully accounting for the fact that enormous portions of the population being served in exactly the communities we just walked through together were biologically far less equipped to comfortably process what they were being served. Plenty of children over the decades were quietly labelled fussy or difficult, or simply told to finish their milk anyway for reasons that, as it turns out, had almost nothing to do with attitude and everything to do with the exact genetic story we've spent this entire night unpacking together. It's a small example in the grand sweep of everything we've covered tonight, but it says something worth sitting with about how easily good intentions can miss an important detail hiding in plain sight. Nobody designing those meal programs was acting with any kind of ill will. They were working from the best general nutritional science available to them at the time, simply without the specific genetic and historical picture we've spent an entire night carefully assembling together tonight. It's a gentle reminder that even well-meaning systems built for entire populations at once tend to work best for whoever happened to shape the assumptions sitting quietly underneath them, and tend to quietly overlook everyone else not through malice, but simply through an incomplete picture nobody had fully filled in yet. Have you ever known someone maybe in your own family who insists milk has never once bothered them sitting right next to someone else who can't get near a bowl of cereal with milk in it without regretting the decision within the hour? Next time that comes up around your own table, you now know there's an entire multi-thousand-year story hiding behind that seemingly small difference, one involving ancient farmers, stomach pouches, steppe migrations and famine, all quietly compressed down into one ordinary everyday moment of mild digestive disagreement. It's worth being careful with numbers like these too, and saying this plainly rather than letting a statistic imply more than it should. None of this works as a strict guaranteed rule for any individual person sitting in front of you tonight. These are population-level patterns built from averages across huge numbers of people, not a fixed destiny stamped onto anyone based on where their ancestors happen to come from. Plenty of people with deep Northern European ancestry struggle with dairy anyway. Plenty of people from backgrounds statistically less likely to tolerate it can finish a bowl of ice cream without a single complaint. Biology, as we've spent this whole night discovering together, loves patterns, but it has never once promised anyone a perfectly tidy exception-free rule. If you're watching this tonight and you happen to fall into that quieter exception yourself on either side of it, that's not a contradiction of anything we've discussed. It's simply a reminder that every single number in this story represents thousands of individual lives, individual bodies, individual family trees, each one carrying its own particular mix of inheritance, never perfectly predictable from a single average alone, no matter how carefully researchers happen to calculate it. There's a small, almost funny postscript worth adding here before we move any further into tonight's story. For the vast majority of human history we've walked through together, there was no real fix available for any of this beyond the clever cultural workarounds we discussed earlier. Careful fermentation, cautious portion sizes, or simply avoiding dairy altogether. Today, anyone struggling with this exact ancient biological pattern can walk into an ordinary shop and pick up a small tablet capable of temporarily doing the work that stubborn little genetic switch never quite finished for them personally. An entire multi-thousand-year evolutionary struggle quietly solved these days by a tablet small enough to fit in a coat pocket sitting on a shelf between the vitamins and the cold medicine. There is something almost comically anticlimactic about that if you allow yourself to appreciate the irony properly. Somewhere a farmer from one of those very first villages we spent time with much earlier tonight would probably find that deeply funny too. Honestly, if you could somehow explain it to them. All that patient trial and error, all those centuries of carefully perfected fermentation technique, all that quiet, unlucky, waiting for a genetic switch that took 1,000 years just to reach 1 measly % of the population. And here we are casually solving the same problem with something roughly the size of a fingernail purchased without a second thought on the way to somewhere else entirely. Which brings us to a natural question worth carrying forward into what comes next tonight. If modern science can now simply hand anyone that missing piece in tablet form, what does that mean for an entire global dairy industry that spent the last century built, marketed and sold, almost as though everyone's body worked exactly the same way? And how much of what we've been told about milk, about its benefits, about its risks, about why we're supposed to drink it at all, actually holds up once you look at it as carefully as we've looked at everything else tonight? That's exactly the question worth sitting with next. Let's follow that thread properly because it leads somewhere your own refrigerator is probably sitting in on right now, whether you've ever thought about milk this carefully before tonight or not. Every single thing we've discussed across this entire story, the genetics, the ancient farmers, the steppe migrations, the famine, the convergent evolutions scattered across half the planet, eventually funnels down into one small unremarkable moment, happening in kitchens everywhere every single morning. Someone reaches into a refrigerator, picks up a carton and pours. Nobody standing in that kitchen is thinking about any of what we've spent tonight uncovering, and yet that carton itself carries the fingerprints of every single thing we've talked about, whether the label on the front ever mentions a word of it. Somewhere around the middle of the last century, milk stopped being simply a food and quietly became something closer to a symbol. Posters in doctors' offices, advertisements plastered across magazines, a small carton placed in front of practically every school child across large parts of the world at lunchtime, without much question asked about whether that particular child's body actually wanted it there. Milk during this stretch of the 20th century wasn't just something people happened to drink. It was something people were told repeatedly, confidently, almost as an article of faith that a healthy body simply could not properly do without. Part of that confidence, to be fair, grew out of a genuine, well-documented public health problem. In the early decades of the 20th century, a condition called rickets caused by a lack of vitamin D and the weak, poorly formed bones that come with it affected shocking numbers of children across industrialized cities, especially in places with long, dim winters and crowded urban air that blocked out a good deal of the sunlight. Bodies need to produce that same vitamin naturally. Public health officials landed on a remarkably clever fix. Rather than trying to change everyone's sunlight exposure directly, an impossible task in a smoky industrial city, they began adding vitamin D straight into milk itself during processing, turning an already widely consumed drink into a delivery system for exactly what deficient children needed most. It worked remarkably well. Rickets rates dropped sharply within a generation across the countries that adopted the practice, and milk earned a reputation not entirely undeserved at the time as something close to a genuine medical intervention, wearing the disguise of an ordinary breakfast drink. From there, though, the story shifts from careful public health policy into something closer to full-blown cultural mythology. Advertising campaigns throughout the later decades of the century leaned hard into that earned reputation, stretching it well beyond what the original Ricketts research had ever actually claimed. Milk wasn't just good for preventing one specific childhood deficiency anymore. It became, in the popular imagination, simply good full stop for practically everything. Strong bones, growing muscles, general all-purpose wellness marketed with a confidence that rarely paused to ask whether every single body drinking it actually needed, or even comfortably tolerated what it was being sold. Perhaps the most famous example, at least here in the United States, involved a long-running advertising campaign built around a single oddly endearing visual gag. Famous faces, athletes, actors, musicians photographed with a thin white mustache left behind after a glass of milk paired with a short, punchy question, asking whether you'd had yours today. It became one of the most recognizable advertising campaigns of its era, plastered across magazines and billboards, for years remarkably effective at keeping milk lodged firmly in the cultural imagination, as something practically mandatory, right alongside brushing your teeth or getting a good night's sleep. There's something almost charming looking back on it now about how completely that particular image took over an entire generation's sense of what a healthy life was supposed to look like. A thin white smear above someone's lip somehow became shorthand for vitality itself, plastered across enough magazine pages that an entire decade of children grew up associating milk with celebrity, with athleticism, with a kind of aspirational glow that had, if you think about it honestly, almost nothing to do with the actual biology sitting underneath the glass. Here's the detail that campaign, brilliant as it was from a purely advertising standpoint, never once addressed. A meaningful percentage of the exact population looking up at those billboards as we spent an entire earlier part of tonight discovering together, could not comfortably drink a full glass of milk at all without some degree of discomfort afterward. The marketing was universal. The biology, as it turns out, very much was not, which brings us into the more recent chapter of this story, the one where science finally started catching up properly with the biology we've spent tonight exploring, rather than simply papering over it with confident advertising. Lactose-free milk, now sitting on grocery shelves practically everywhere, works through a wonderfully simple bit of applied chemistry, and it's worth understanding exactly how, because it circles back beautifully to something we discussed much earlier tonight. Manufacturers add a small amount of lactase, the exact same enzyme your own small intestine would normally produce, if your body carried that genetic switch we spent so long tracing back to its origins, directly into the milk itself during processing. That added lactase gets to work immediately breaking the lactose down into simpler sugars before the milk ever reaches your glass, meaning your own digestive system never has to do that particular job at all. In a very real sense, every carton of lactose-free milk sitting in a modern grocery store is performing mechanically outside your body exactly the function that single-swapped genetic letter performs automatically inside the bodies of people who happen to carry it. Here's a question worth sitting with for a second. Doesn't it feel almost poetic that an entire industry eventually built a factory-scale solution to precisely replicate what one tiny accident of genetic history gave certain people for free. 7,000 years after farmers in Poland worked out how to strain lactose out of milk, using nothing but a perforated clay bowl and patient trial and error. Modern food science essentially arrived back at the same basic idea, dressed up in stainless steel equipment and quality control certificates instead of pottery and guesswork. There's another recent wrinkle in this story worth knowing about, one that shifts the conversation away from human biology entirely and points it surprisingly back at the cows themselves. Researchers studying dairy cattle discovered that not all cow's milk is chemically identical. A particular milk protein called beta-casein comes in at least 2 common genetic variants. Researchers label them simply as one type and another, and some evidence suggests the more common modern variant may break down during digestion into a compound that causes mild digestive discomfort in certain people, entirely separate from lactose itself. Milk sourced specifically from cows carrying only the older, less common variant has been marketed in recent years as an easier-to-digest alternative. It's a curious little mirror of everything we've spent tonight discussing if you think about it properly. Just as human populations carry their own scattered patchwork of genetic variation, shaping how comfortably each of us handles dairy, it turns out the animals producing that dairy in the first place carry their own quiet genetic variation too, shaping the product before it ever reaches a human digestive system at all. 2 separate stories of genetic diversity, one on each end of the same glass of milk, neither one aware the other existed until researchers finally thought to look closely at both sides of the equation together. It's worth being fair and careful here because the science on this particular question is still being actively studied and debated among researchers, without full agreement yet on exactly how significant the difference really is for most people. But the underlying idea is worth appreciating regardless of how it eventually settles. The story of milk and human digestion, it turns out, may not be quite as simple as one single gene, one single switch, one single explanation. There may be an entirely separate layer of genetic variation hiding inside the cow itself, adding yet another thread to an already wonderfully tangled story. And the frontier keeps pushing further still. Researchers working at the cutting edge of genetic engineering have begun experimenting with precisely editing the genetic material of dairy cattle themselves, aiming to produce milk naturally lower in the specific proteins that tend to cause the most trouble for sensitive digestive systems, adjusting the biology of the animal rather than processing the milk afterward. Separately, an entirely different field of biotechnology has emerged around what researchers sometimes call precision fermentation, using carefully engineered microorganisms, distant cousins of the same yeast that makes bread, rise, or beer, ferment reprogrammed to produce actual milk, proteins without needing a cow, a goat, or any animal at all anywhere in the process. It sounds almost like science fiction the first time you hear it, described properly, and yet it's being actively developed, tested, and in some places sold right now, while you're listening to this story tonight. Try sitting with the strangeness of that for a moment because it deserves a proper pause. Actual milk proteins chemically identical to what comes out of a cow, brewed instead inside a stainless steel tank using engineered microorganisms with no udder, no pasture, no animal involved anywhere in the entire process. Whether or not that particular future ends up reshaping the dairy aisle in any meaningful way remains truly uncertain and honestly isn't really the point worth sitting with tonight. What matters for our purposes is what it represents. The exact same restless problem-solving instinct we've been following since a farmer somewhere first tasted a strange curdled surprise inside a leaking stomach pouch still very much alive, simply wearing a considerably more sophisticated lab coat these days. Isn't it worth sitting with for a moment just how far this particular thread has travelled? A single accidental mutation first appearing in one farming valley thousands of years ago. A clever cultural workaround discovered by accident inside a leaking stomach pouch not long after. Centuries of quiet trial and error refining fermentation technique generation after generation. And now, factories capable of manufacturing the exact proteins found in milk without involving a single living animal in the process at all. Different tools, wildly different eras, but honestly the exact same underlying impulse running through every single step of it. Humans again and again refusing to simply accept a biological limitation as the final word and quietly working around it instead, however long that work happens to take. Let's talk honestly for a moment about where the science currently stands on milk's broader reputation, since that reputation has shifted rather a lot from the confident, simple messaging of those old advertising campaigns. Modern nutritional research paints a considerably more layered picture than milk, being simply universally good full stop for every single body drinking it. Questions about how much milk actually benefits adult bone health, how it compares against other calcium sources, and how individual factors like age, existing diet, and yes, genetic background shape the answer remain areas of real ongoing scientific investigation rather than settled fact. I won't pretend to hand you a tidy final verdict here tonight, because an honest one doesn't currently exist. What I can tell you with real confidence is that the simple, unquestioning certainty of those milk mustache years has given way to something far more nuanced, far more individualized, and honestly, far closer to how the actual biology we've spent this entire night exploring has always actually worked. Does that surprise you at all, thinking back on how confidently milk was presented to most of us growing up? I know it surprised me the first time I properly dug into how much of that old certainty was built more on successful marketing than on settled, comprehensive science. It's not that the marketing was dishonest exactly. It's simply that advertising has never once been particularly interested in the kind of careful nuance we've spent this entire night trying to sit with properly. There's something almost comforting, if you ask me, about walking into a modern grocery store today and finding an entire wall dedicated to milk in every conceivable form. Lactose-free, ultra-filtered, sourced from cows carrying one particular genetic variant instead of another, sitting right alongside oat, almond and soy alternatives that aren't technically milk at all, but have earned the name anyway through sheer cultural habit. That last detail honestly still makes me smile a little every time I think about it properly. An almond has never once produced milk in its entire existence, obviously, and yet there it sits, carton after carton, confidently sharing shelf space with the genuine dairy article borrowing a word that technically belongs to mammary glands rather than nuts. Language, much like the biology we've spent tonight exploring, cares far less about tidy categories than we sometimes assume. If enough people start calling something milk, apparently eventually it simply becomes a milk-dairy background, or not much to the quiet frustration of certain trade organizations over the years. It's a strange, slightly chaotic monument, honestly, to just how seriously our species has taken this one particular problem, generation after generation, all the way from a stomach pouch on a dusty path thousands of years ago to a refrigerated aisle humming quietly under fluorescent lights tonight, which leaves us as our story tonight edges toward its final stretch with one last thread worth pulling together. We've followed one single genetic switch across roughly 10,000 years, through farming villages and steppe migrations and famine and laboratories and grocery store shelves. Ancient herders straining curds through perforated clay, Bronze Age wagons crossing an entire continent, 20th century advertising executives building an empire around a white mustache, engineers today growing milk proteins inside steel tanks without a single animal in sight. All of it somehow tracing back to that one impossibly small change we spent an entire earlier part of tonight getting properly acquainted with. But somewhere back at the very beginning of tonight's story sat one small girl in one small valley whose name we will never know, quietly, living out the very first chapter of everything we've just spent this entire night exploring together. Every laboratory, every advertising campaign, every carton sitting in every refrigerator tonight. All of it exists because a body like hers thousands of years ago quietly did something nature never expected it to do. It feels like the right moment to go back and finish her story properly. It's time to go back to her just for a little while before we let this story rest for the night. A small girl in a small valley somewhere in what we now call Central Europe, kneeling by a fire with a bowl of goat's milk in her hands, doing something her own body was never supposed to be able to do. We can't know what happened to her afterward. History never wrote her name down anywhere, and it never will. But we do know with complete certainty that somewhere along an unbroken chain of mothers and daughters, sons and fathers stretching from that one ordinary morning all the way to tonight, somebody kept surviving. Somebody kept having children who survived too. Through famine, through disease, through migrations across entire continents, through 1,000 years of near total silence, where this trait very nearly disappeared from the human story. Completely, somebody somewhere always managed to carry it just one generation further. Picture her one more time, if you'll indulge me, all grown up now, years past that small bowl of milk we first met her beside. Perhaps she has her own children by then, her own fire, her own quiet worries passed down the same way her mother's once were. She never learned the word mutation. She never once heard the word gene. She almost certainly never thought of herself as unusual in any grand sense at all, simply as herself living an ordinary life, doing ordinary things, entirely unaware that something invisible inside her was about to travel further and last longer than any single choice she ever consciously made. Maybe it was her. Maybe it started somewhere else entirely in some other valley we'll never hear about, and hers was simply one thread among many scattered across an enormous continent. It honestly doesn't matter, not for the purposes of tonight. What matters is that her story, real or symbolic, whichever way you'd like to hold it in your mind as you drift off tonight, is your story too, whether you happen to carry that particular genetic switch yourself or not. Every single one of us sitting here tonight is the end result of an unbroken chain of people who managed against long, uncertain odds to survive long enough to pass something forward. We started this story with one small, strange fact. That drinking milk as a grown adult should never have been possible for any of us by every rule nature had followed for hundreds of millions of years before humans ever existed. And somehow, we ended up walking through nearly the entire sweep of human history to properly understand how that one small fact came to be true for so many of us today. We watched a single letter swapped out of billions quietly leave a genetic switch stuck in the on position long after it was supposed to close. We followed that switch through 1,000 years of near extinction, carried by only a handful of scattered families one difficult winter away from disappearing forever more times than anyone could count. We watched farmers domesticate wild, dangerous animals through nothing but patience and quiet courage, and then faced with bodies that still couldn't properly digest what those animals provided, invent an entirely different solution out of nothing more than a leaking stomach pouch and a willingness to try the strange thing sitting inside it, instead of throwing it away. We rode alongside herders crossing an entire continent on wooden wagons, watched a genetic trait finally catch the momentum it had been missing for 1,000 quiet years. We uncovered a truth considerably harder to sit with than the comfortable story most of us grew up believing, that survival for a great many of our ancestors came down not to thriving, but to simply not being the one who died during the worst of it. We travelled to Sudan and Kenya and Arabia and India and Southern Africa and found the exact same problem solved again and again independently by people who never knew the others existed, as though the pressure itself simply refused to be ignored, no matter which corner of the earth it happened to land in. We sat with the uncomfortable honesty of populations across the Americas who never needed this particular story at all, having spent those same thousands of years writing an entirely different, equally remarkable one of their own. And we arrived, finally, in your own kitchen, your own refrigerator, your own dinner table, where an entire multi-thousand-year story now sits quietly disguised as something as ordinary as a carton of milk. That's rather a lot of history hiding inside something most of us have never once thought twice about while pouring it into our morning coffee. If there's one thread running underneath every single part of tonight's story holding the whole thing together, it might be this. Almost nothing about the world we take for granted arrived the way we assume it did. Not through some single obvious moment of triumph, but through centuries of quiet accumulation, most of it invisible, most of it unremarkable, while it was actually happening noticed by absolutely nobody until long after the fact. The people living through any single chapter of tonight's story, the herders straining curds through clay, the families crossing an entire continent by wagon, the researchers piecing together fragments of ancient bone, none of them experienced what we just experienced tonight. A tidy, complete arc beginning to end cause leading cleanly to effect. They only ever had their own small piece of it, their own single ordinary day, never knowing which small habit, which quiet choice, might end up mattering thousands of years later to somebody they would never meet. Here's what I keep coming back to out of everything we've covered together tonight. This entire story, every single piece of it was never really about milk at all. Milk was simply the thread we happened to be following. What we were actually tracing this whole time was something far bigger. The story of how a species keeps adapting in two directions at once. Biology slowly reshaping itself across thousands of years, and culture, human ingenuity, human stubbornness, moving far faster, working around whatever biology hadn't caught up to yet. Neither one ever really finishes the job alone. They've been trading the lead back and forth for as long as we have any evidence of either one existing at all, and if tonight's story taught us anything properly, it's that neither one shows any sign of stopping now. Biology moves slowly, patiently across thousands of years, one accidental letter at a time, with no particular hurry and no particular loyalty to any single outcome. Culture moves considerably faster, impatient by comparison solving today's problem with whatever is close at hand, a stomach pouch, a perforated bowl, a laboratory, a factory, rarely waiting around for evolution to eventually catch up on its own schedule. Tonight's story only makes proper sense once you hold both of those forces in your mind at the same time, watching them push and pull against each other century after century, neither one ever quite finished, neither one ever quite in charge alone. Think for a moment about everything currently sitting inside your own body right now tonight that you've never once had reason to question. Traits you assume are simply normal, simply the way things have always been, the same way that little girls' own neighbours once assumed milk was only ever meant for the very smallest children. How many of those quiet, unquestioned assumptions about your own body are in reality exactly like the story we just spent an entire night unpacking together? Not permanent laws of nature at all, just very old habits still waiting somewhere down the line for their own small, unnoticed exception to eventually show up and prove them wrong. It's a strange kind of comfort thinking about it that way late at night like this. We spend so much of our lives assuming the shape of things is fixed permanent, simply the way the world works and always has. And yet almost everything we walk through together tonight began as an exception. One person out of step with everyone around them quietly carrying something different, for reasons nobody around them could have possibly explained at the time. Somewhere right now, similar exceptions are almost certainly happening again in bodies we'll never hear about in ways none of us will live long enough to fully understand. History, it turns out, is still being written, the exact same quiet way it always has been, one unremarkable, unnoticed moment at a time. I find something quietly hopeful in that thought, if I'm honest with you, especially at this hour, especially with everything else going on in the world right now. Change, real change, the kind that eventually reshapes an entire species, does not always arrive with fanfare. Sometimes it arrives exactly the way this story did. One tiny unnoticed accident in one ordinary person, in one ordinary place, carried forward quietly by people who had no idea what they were protecting, for far longer than anyone would have reasonably expected it to survive, and then given enough time, enough patience, and admittedly enough luck, it becomes so completely woven into everyday life that nobody even remembers to ask where it came from anymore. We live, most of us, expecting change to look dramatic. A single decisive moment, a clear before and after, something worth marking on a calendar. Tonight's story suggests something gentler, and honestly, a little more forgiving than that. Real change, the kind that actually lasts, often looks like almost nothing at all while it's happening. A handful of quiet carriers scattered thin across an entire continent, holding on through centuries where nothing seemed to be happening whatsoever, right up until quite suddenly everything had already changed around them. If you happen to be sitting somewhere tonight wondering whether something small you're carrying, some quiet effort, some quiet hope, actually matters in any lasting way, this particular story would gently suggest that it very well might, even if you never live to see exactly how. You are living proof of that particular kind of patience tonight. Every strand of hereditary material sitting quietly inside you carries some version of this same story, thousands of tiny accidents, most forgotten, a rare few remembered only because they happened to matter, all stacked one on top of another, going back farther than any of us could ever properly count. You are not simply here by chance in the shallow sense of that word. You're here because an almost unbroken chain of ordinary people, none of them famous, most of them never written down anywhere, kept managing to survive generation after generation, long enough to eventually produce you sitting exactly where you are right now, listening to a stranger's voice tell you a story about milk of all things late at night with the lights turned down low. That's worth sitting with gently for just a moment before you drift off tonight. Not with any pressure attached to it, just with a quiet kind of wonder, the sort that tends to settle a busy mind rather than stir it up further. I want to say something honest before we close this story out properly. Of everything I've ever put together for this channel, this particular journey, following one small mutation across 10,000 years of human history, has been one of my own favourites to sit with, research and slowly build for you. There's something about a story this small in its origins, one single swapped letter, and this enormous, in its consequences, an entire species relationship with an entire category of food that I don't think I'll stop thinking about again anytime soon. I hope wherever you are tonight, whatever brought you here, it left you with that same quiet sense of wonder it left me with somewhere along the way. Thank you honestly for staying with me through this whole journey tonight. Stories like this one take a great deal of careful research and a great deal of quiet, patient work to put together properly, and having you here all the way to the very end means more than a quick line at the end of a video can really capture. Whether tonight is the first time you've ever found your way here, or you've been settling in with me for a while now, I'm truly glad you spent these particular hours with me out of everything else you could have chosen to do with your evening instead. If this particular story kept you good company tonight, easing you gently towards sleep the way it was always meant to, it would mean a lot if you left a like on your way out and subscribed if you haven't already, so the next story finds its way to you without you having to go looking for it yourself. And if you have a moment before you drift off, I'd love to know down in the comments which part of tonight's story surprised you the most. I read every single one and I promise they never go unnoticed. There are so many more stories like this one waiting to be told. Quiet, ordinary-seeming details from history that once you actually look closely enough turn out to be carrying entire civilizations on their back. A common spice, a simple invention, a word we use every day without ever once wondering where it actually came from. I'll be back soon with another one, and I hope whenever that night comes you'll be right back here again, lights low settling in, ready to disappear into somewhere else entirely for a little while. For now though, let this be where tonight's story finally rests. Somewhere out there, thousands of years ago in a small valley, most of us will never see a small girl finished her bowl of milk, entirely unaware that she was carrying the beginning of everything we just spent this whole night discovering together. She never knew any of this. She never needed to. She simply lived ordinarily quietly the way most of us do, and that turned out to be more than enough. And somewhere tonight in your own home, wrapped in your own blankets, carrying that very same ancient patient thread inside you, so are you. Close your eyes if you haven't already. Let the rest of tonight take care of itself. Sleep well. I'll see you again soon.